So we will speak now about Internet of Things, technologies, application, and challenges. First, we will speak about the introduction about Internet of Things. As I said before, Internet of Things, it is a big network.
जरूद्दीन शहर है, फिर अरविंद है, वो प्रभात के पास है सब डिटेल.
Yes.
ऑडियो ऑफ कर लो करण. ऑडियो. Continue.
Can I continue? Okay. So Internet of Things, I had said before, it is a big network which can connect people, things, application, data from the internet. Now, how large is the internet IoT network? We say it is a big network. So how large is it? As all of us know, if we have one family, inside is the family consists of 5 members, mother, father, and 3 sons. At least we have 6 mobiles, or at least we have 6 devices connected to internet. So these devices which is connected to internet is called IoT devices. And this year, prediction said by the end of this year, we will have 50 billion things connected to the internet. That means that the number of devices which is connected to internet exceeds the number of people in the earth. So you can imagine how Internet of Things is important. Now, if you are speaking about economy, you are going to control devices which exceeds the number of people. So if you speak about economy, if you are take $1 from each devices, how much money you will take per day or per month? So if you speak about technology, if you speak about security, if you can control 50 billion things through the internet, if you can control, if you can track, so you can have secure and have more controllable of the things during the world. That's why Internet of Things is very, very important technology nowadays. So Internet of Things service support. Which service we need to support IoT? As we say, Internet of Things is a big network. So big network means I have more IoT devices, which is the purpose of these devices is to collect. After we will collect the data, and then it will become to analyze. After we will analyze this data, we are going to process segment of huge number of data because I have huge number of sensors network. So after collecting and analyze, I will take operational control based on this information. So to enable this service of IoT, we need database, IoT database. So to make IoT database, cloud computing is support will be needed. And if I speak about huge number of sensors, I will speaking about huge number of data. So it's big data. So we need big data support will be also needed to make IoT application is possible. So how we can see the influence of Internet of Things? We can see the influence of Internet of Things in 4 measures. First is people, process, data, and things. If we will speak about people, actually I believe that Internet of Things technology started to appear because people will become more lazy. People want to stay at home and they want to control everything through their bed. They don't like to go to turn on or turn off the lights. They don't want to turn on or turn off the television. They want to control everything while they are staying at home. So now by using Internet of Things, more things can be monitored and controlled. So the people become more capable. Process. Now, if you are speaking about Internet of Things, we will have more users and machines. Machines mean devices which can be collaborate in real time. So if we have more users and more machines collaborating in real time, what will happen? More accurate decision is accomplished, or more complex tasks can be accomplished in lesser time. If you will speak about data, now we are speaking about huge number of data, as we said. So collected more frequently, it will help us to make more accurate decision making. Finally, things. Things, I said everything. Everything means chair, table, fans, human himself. Nowadays, by using the technology of wireless body area network, now we can include one chip inside the body of the human. The chip, it can has IP. It has IP, now the human become IoT device. So the human can be connected, can be tracking, can be monitoring, can be controlled also through the Internet of Things. Now also, the value of the thing become more valuable. For example, your mobile. Your mobile, if you are using your mobile, your mobile is considered the simple IoT device. But when you are using your mobile only for camera, browsing internet, but by using Internet of Things, your mobile will become more valuable. Now you can use your mobile to control your car, you can control your fridge, You can control anything you can control by using mobile. So by using Internet of Things, the things themselves will become more valuable. Now, if we will speak about IoT applications. Nowadays, IoT, you can find IoT applications in all our daily fields. But one of the most important is security. Security as a military-based application. So by using IoT devices, now we can make more surveillance application, alarm, real data object, and people tracking. So now by using IoT, you can track deserts. But in the case of military, if you can see USA now, they are using this drone helicopter. This drone, they can go track any country you want without losing any soldiers. So this is the powerful of IoT applications. So security is a major concept or the major application of IoT. Now we speak about transportation. If we will speak about transportation, we have a new field of Internet of Things. It's called Internet of Vehicles, IOV. Now transportation is the most important, especially in India. If you drive car in India, you can drive anywhere, as I have learned, because this is a big jam. Million of cars is going on. So the normal traffic camera cannot help. The normal way to track the cars cannot be held. Because if we are based on camera, if you will based on only human, it cannot be held to make control in the transportation. And also, if you see what is happening in South Korea, how South Korea now success to beat COVID-19. They started to beat COVID-19 because of Internet of Things, because they are using mobile cameras, they are using chips inside the people to track the people. So Internet of Things have make a lot of contribution during nowadays, because based on this camera, the people who considering Internet of Things from long time back, now they success to beat this COVID-19. So that's why you can see now all the people is interesting now to make cameras. They are making IoT devices in the roads, in the streets, in the people, in the mobile. So now they can track. So in transportation, if you can go to France, you can find one subway. This subway is walking without any drivers. This subway is train. It is surrounded by sensors. So the sensor will drive the train. It will go to the station. Automatically, it will stop. The sensor will open the doors. People will enter the car, the transportation, and then the door will close automatically and go to the next way. This is the power of IoT devices in transportation, and more also in transportation. Now they are making cars speak to each other. If the car is speaking to each other, it will no collisions, no traffics, no accidents. This is a base of IoT application in transportation. If you will speak about healthcare, you can imagine, I just said about healthcare IoT. Now, a lot of mobile application has been developed how to track COVID-19. I only focus on COVID-19 because it is the real-time problem. All of us are suffering from it. So based on IoT application, nowadays, a lot of application has been developed. How you can predict about COVID-19 by using AI and IoT. How you can track your blood, how you can track your lungs, how you can use wireless body area network to track the COVID-19 and how to predict the COVID-19 in the early stage. And more in healthcare application. Utilities, if you speak about utilities, we will speak about the gas and water tracking, smart meters. Now, no need to make the people go to read your meters at home. No, we can make smart gas meters, smart water meters, which will read your meter and send it automatically to the company, and then you can pay your bill automatically without any delay. And more, if you speak about manufacturing, we will speak about product chain. Also facility management, smart building, and smart campus automation. Now, let's go to speak about IoT and machine-to-machine ecosystem. If we will speak about service, we have business service provider or business solution providers. A lot of companies help us for this business provider, for example, Exida, Josper, and Core. If you will speak about network operators, like a lot of networks support us with the networking to allow us to use Internet of Things. For example, Vodafone, Cisco. If you will speak about also software, all software we want to develop IoT applications can be found by this company's organization, Google, Samsung, Huawei, Oracle. A lot of companies now is going. Microsoft also, you can find all of this IoT, Bolt, IoT softwares available now. If we speak about hardware, we speak about GPS chips, We speak about wireless sensing network, about RFID. We can use also these companies is now available. Mac is working now, Sony, LG, and Samsung. They are the big companies now. They are providing us to the software and hardware which allow us to design our IoT applications. Now let's go to speak more specific about IoT. Let's start with the IoT layers. How many layers I have in IoT? You can see this image. If we go from down to up, we can find first one in the bottom down, sensors, connectivity, and network layer. And we can find this layer, sensors, networks, tags, RFID, barcodes. And in the above of this layer, we will have gateway and network layer. This is the gateway for the sensor to the internet. So it is called gateway and network layer, where we can find the WAN, wide area network, or Wi-Fi Ethernet gateway connection. If we speak about mobile, we will speak about LET or LTEA. Above of this one, we will find the management service. So in the management service layer, we will speak about the device modeling, configuration, security control, analysis of the data, and finally we'll find the sector of this application, which is called application layer. So all of this is providing us environmental application or transportation application or surveillance application. Let's go one by one to each layer. First of all, let's start with the sensor layer. So sensor layer, if we will speak about sensor layer, it is the basics layer. Everyone know about that. Sensor layer, which is based on down, you will find the tag or RFID, or we can use also sensors like GPS sensors, catalytic sensors, solid state sensors. All of this sensor is going to collect the data and then it will send to the next layer. So to send the data to the next layer, we need gateway. So how to connect to your gateway? How the sensors and this sensor layer connect to the gateway is you connect through LAN, local area network like Wi-Fi or Ethernet, or they can use PAN, personal area network, by using ZigBee, Bluetooth as 6LoWPAN or wired. Now, let's see what is the mean of sensor layer, or what is the sensor layer made up of. For sure, it is from the name, sensor layer. So it is made of sensors and smart devices. And I said before how we can say what is the IoT device. IoT device, it is any device which has IP and it can connect it to the internet. So we have sensors and we have smart devices. These sensors and the smart devices will real-time information to be collected and processed. So the main measure of these devices is to collect the data in the real time. This sensor has some properties. For sure, we know all of the sensors is based on battery. Most of them is powered by batteries. And this battery is chargeable, but actually we are using sensor in some deserts or volcanoes under the water. So to recharge the battery is not easy task. So this batteries is low power, or these sensors are low power and low data rate. That's why most of the sensors IoT network is formed in wireless sensing network. Now, this is a big question is here. What's the difference between wireless sensing network and IoT? Because this question is very important. Some people say, okay, wireless sensing network, it is also we have sensors. This sensor will collect the data and then send to the internet or to the cloud or to the servers. Now, by your definition, also Internet of Things technology is doing the same. Sensors collect the data and send to the internet. To explain the difference between wireless sensing network and IoT, I will give very simple example. For example, if I am sitting in one room, this room, I want to track this room. So to track this room, I will put one sensor in that hole. We can say motion sensor. So this motion sensor, if anyone inside, for example, if anyone inside the room, the motion sensor will give you read 1. If there is no one in the room, the motion sensor will give you 0. So during the night, I expect that the reading of this sensor is 0 because no one inside the room. So if I will make the sensor send the data after every 3 minutes. So at the night, every 3 minutes, it gives me 0, 0, 0, 0, 0. So I will have huge number of data unuseful for me. Because if it is 0, there is nothing to do with 0. I need only data come when it is changed from 0 to 1. But if it is 0, no need to send 0 to the internet, which make huge number of data, unuseful data to me. So this is a technique of wireless sensing network. Sensor sense and send, sense and send. So IoT technology use the same concept of wireless network, but make it more smart. How? By adding one stage between sensing and send. Between sensing and send, I will add one process called processing stage. In this processing stage, instead of sending the data and send directly to internet, there is one hardware will collect the data from the sensor and process. Check. If the data is 0, don't send to the internet. If the data change from 0 to 1, now you have to send the internet. So now what will happen? I reduce the number of huge data which send from sensors to internet. I have sent only the important data. This is a simple example between a difference between IoT and wireless network. So wireless network, it is under the umbrella of IoT. So the sensors, because I said sensor is low power and low data rate, I will form the sensors down in this layer in terms of wireless sensing network. So I will use the concept of wireless sensing network that sensors sense that collects the data and send, sense and send. But instead of sending to internet directly, I will make one stage. That is the next stage. It is network gateway layer. Okay, so if I have 10 sensors and these 10 sensors is doing different tasks, so I will group, make groups of these sensors based on the purpose. If I have some sensors for military, I will make group for military. If I have groups for body, I will make group for body. So the sensors are grouped according to their purpose and data type. Now, I said, now the sensors collect the data. Now they have going to send. Now, how they will send? They will not send to the cloud. They will send to the next stage. It is the gateway stage. So in this stage, I no need for WAN. I need only LAN by using Ethernet or Wi-Fi, local area network, or some devices using personal area network. It is ZigBee or Bluetooth or 6LoWPAN. So you can find some devices connect to the gateway by using Wi-Fi. You will find some devices connect to the gateway using Bluetooth. It is based on the application and based on the purpose. So if the sensor not require connectivity LAN to gateway, if it is directly sent to the internet, now it is not Internet of Things. It is called wireless sensing network because now it is directly sent to the internet. Now let's go to the next step or next layer. We finished sensors layer. Now let's go to the gateway and network layer. Now sensors collect the data and it will send by using LAN or PAN to the gateway. Now the gateway is consist of, as I said, some microcontroller like Raspberry Pi or Arduino in embedded system or same module. If you speak about GSM module, if you speak about access point. So this gateway will collect the data from the IoT devices. After it will collect the data from the IoT devices, now it will going to send it to the end device, or we can see the server, or send it to the cloud, or send it to the data center. It will send through the WAN, because now I'm speaking about big distance, so wide area network through 3G, LTE, or LTA, to speak about GSM module, mobile connection, or during Wi-Fi or Ethernet also. Now, what is the challenge is in this layer? This layer have a lot of challenges. Because this layer, now I'm speaking about IoT. IoT, as I said before, big network. So if I say big network, I'm expecting big data, big collected data. So it should support massive volumes of data. A lot of data will come to it. So how it will be control this data? So it needs reliable performance to provide regarding private or public or hybrid network models. These network models are designed to support quality of service, also scalability, bandwidth, security, and for sure, all of them you have to consider the energy efficiency, because the energy efficient is the most fact or the most parameters. It is make my network efficient. Now, as I said, this gateway will collect the data from different networks. For example, I have some networks, some devices connect to the gateway by using Bluetooth. I have another devices connect to the gateway by using ZigBee. I have another network sensors connect to the gateway by using LAN. So I have different type of network in single IoT platform. So this gateway should be integrate this different networks in efficient way. As I said, we have aggregated various type of protocols. I have Wi-Fi protocols. I have LAN protocols. So we have different protocols in the same platform. So this network should be scalable for efficient servers wide of application and large scale networks. Now let's go to IoT management service layer. In IoT management service layer, we will speak about operational support system, service analytic platform, security, which is the most important issue in this layer. If we speak about business rules management, business process management. For example, if I will speak in this, it is now data sent to the end device. Now in this cloud or this, I have to make information analyze, security control, processing modeling, device management. And in device management, I have to consider periodic IoT data, filtering. For example, if I have data come from the medical emergency sensor, so this data should be processed first. If I have different network down, one is for patients, one for whom. So which one is most important? Here is the periodic. So now, if the data come from the patient medical emergency sensor, this one should be processed first. So this can be happen in the management service layer, which took data management. So if you will speak also of this in data management layer, we will speak about the abstract business control model. Business control model, if I will speak about business level, I cannot, when I process the data, if I'm speaking about in the level of business model, I have to make data abstract. Data abstract means no need to send the whole information to the person. I have to give him abstract to take decision based on the data collected by sensors. I cannot send whole data, I have to make data abstract. Then, based on these data abstractions, information extraction processing, and now the business model can give the decision based on this abstract data. Now, if we will speak about the last layer or above layer is application layer. All of these layers, sensors layer, collects the data, network layer collects the data from the sensors and send to the management layer. Management layer will process, analyze, and abstract, and then this will be effect in the application layers. So in application layer, we have horizontal market and sector. For example, if we speak about supply chain, it will affect on the transportation. People tracking, it will affect on healthcare or military. Surveillance will go to the military application. If it's fleet management, it will use the environmental application. So this application is based on the network type and the coverage. We can define the application based on the coverage, how many you can cover, size, heterogeneity, business model, as we spell real data time or unreal data time. So for example, if you will speak about personal and home, we will speak about IoT scale of individual home only, small. If you will speak about enterprise application, we will speak about the scale of community. If you will speak about utility application, we will speak about region or nation. If you will speak about mobile, mobile means it can spread, mobile can be used here, it can be used here, it can be used here. So mobile application need mobility. So if we see this figure, we can divide. If I have to speak about smart home, the network size will be small. Inside the home, how the sensors can connect, it will be by using LAN, 3GP, 4G, if you speak about the GSM module through the internet. And the bandwidth is very small because it is the home, smart home small. If you speak about office, still small, still the same connectivity network, still the bandwidth is small. If you go to here to smart agriculture application, we will speak about satellite. Now we have field, big field. So this field will connect to the satellite, and this satellite will go to the analyze the data. So we speak about the bins small or medium. If you get transportation, now transportation is the biggest. So the network will be large network. For sure, we cannot find LAN here. We will find VLAN, 3G, 4G, satellite for sure communication, and the bandwidth will be medium to large. Now, this is a summary. If we have a smart home, it will be internet. If we have smart city, city management, resource management, police network, and this give you only application. If you speak about smart agriculture, you speaking about area monitoring, condition sensing, fire alarm. A lot of this application is existing nowadays. It is not in future. It is already existing. All of this. we speak about smart city, we'll speak about city management, resource management, and so on and so forth. Now let's go to IoT technology. I am going fast because time is going. Now let's speak about what is the technology which makes IoT possible. First one is RFID. RFID, it is radio frequency identification. If you see this figure, it is consists of an antenna, reader, and write. One is antenna, which will connect to the reader. It will read the data from the antenna and reader. So it is shape. About this shape is the sense, which is connected to internet. So the antenna is used to receive. Sometimes this antenna is used also to recharge. You can charge by using the RFID tags, by using the antenna, or also antenna also using to transmit the data between the reader and the chip. This is the technology of, I said before, in sensor IoT devices, we have sensors or RFID. This RFID is one of the technology which is used to make IoT devices. This antenna is used only in the most used in the home device or home application because it is no need for distance, small distance, PAN, person area network. Why? For example, one example of this RFID in to make your fridge smart fridge. For example, everyone nowadays who cannot go outside to buy at least milk, for example, milk. So sometimes you have 5 cartons of milk inside your fridge, and then this milk are finished. So now you want to buy again. Instead of take the decision, the fridge can take decision. So you can put RFID inside the door of the fridge. When you take one milk, now the RFID will change that one minus. Again, one milk minus, one milk minus. If reach to that only one milk inside your fridge can take order, give order to the supermarket that I need 5 others milk. This is a small use of RFID technology by using IoT technologies. Now, what is the research development in this area? How to design the chip? How we can use this RFID can support stream of data support? How to make the automatic meter readings? How we can use it in home automation application, as I give example of smart fridge. How we can use also it in the vehicles and transportation application. These are the research and development in this area. And also security issue. Security issue in RFID is the most hot topic nowadays. Now let's go to the most important technology which make IoT possible is the wireless sensing network. As I said before, wireless sensing network, it is under the umbrella of Internet of Things. As I said, the difference between them. So Internet of Things is a big umbrella. Under the umbrella, we have wireless sensing network. As I said, all the sensors, efficient, low cost, and low power devices, which are using for remote sensing and collecting data. So now, most of the sensors are, as I said, powered by batteries. So we can measure the network lifetime based on the battery lifetime. If the battery is on, network is on. If the battery is off, network is off. So that means if you can extend the network lifetime, you are successful to prolong your network. If you not success to reduce the network, the power consumption, your network will be end fast. So wireless sensing network, it is very useful way to help us to reduce the power consumption by using the wireless sensing network solution we will discuss after some time. Now let's speak about cloud computing technology. We speak now in technology, RFID technology, wireless sensing networking. Now let's go to the cloud computing technology. As we say, IoT is need to collect and analyze huge number of data. And this data will be turned on operational process. So most of IoT devices not have BC or smart level. They don't have BC or smart level. So we need some devices, we need some devices can overcome the lack of software, firmware, memory storage, data processing, and hardware also. Who can help us in this? It is the cloud. So any software IoT devices is not available, SaaS, software as a service, can help us. If any hardware we want, it is not available in IoT devices, PaaS, platform as a service, cloud computing service can be helped. If I need any database, IaaS, infrastructure as a service can help us. So the cloud computing service is very important to make IoT technology possible. Now, what is the research and development in this area? In this area of IoT, we can speak about, as I said, all this the IoT devices are small memory, limited processing, and battery operated. So now we have to overcome this. How to make the sensor make small memory means how to overcome small memory and we have to collect more data. How to solve this problem? How sensor have small limited processing. So if you give it complex task, mathematical task, it will increase the computation. If you increase the computation, means you are increasing the power consumption. And if you increase the power consumption, that means you decrease the network lifetime. So this is the most familiar or most famous issues that IoT devices are suffering from. Second, as I said, in one single platform, we are using different network. We are using some devices connect to the gateway by using IP4 version 4. Some of them connecting to the IoT platform by using IP version 6. So how to integrate all of this technology in one platform, it is one of the biggest challenging also facing Internet of Things. Security for sure. Data authentication, data authorization, user authentication, how to make things to things as control, how to make public and private key management, how to make low overhead protocols, low complexity protocols to achieve the security, privacy, and integrity. It is the most big challenging facing IoT technology. And finally, energy and resource management. How to reduce, as I said, the energy, the most two parameters is affecting energy is the distance and size of the data. If you are going from genuine gate to our center, computer science center, if you walk all of this distance to receive one letter to the center, you will walk. Distance is big, so you are consuming power, so your network lifetime is very slow. But if you say, I will go from the Genio main gate to KC, and then I will give my message to another one. This one will walk from KC till T point, and then from T point, another one will walk to another T point, and this another T point to center. Now you are dividing the distance, so your network distance reduced, power consumption reduced, network lifetime will be long. And if you speak about packet size, if I'm carrying huge bag, if I carry huge bag, if I will huge bag, walking, carrying huge bag, that means I'm consuming both more power. But if you reduce the bags, instead of carrying huge bag, I will make two bags, small bags, and again small bag, two small bags, again two small bags. So if you reduce the packet size, you reduce the power consumption, and you belong to network lifetime. Now, if you speak about IoT technology, you can see this image. You can see this network which connect to the gateway, which is the mobile, by using ZigBee protocol, and then mobile to the access point by using Wi-Fi, and by using Wi-Fi, and the access point to the server by using LTE. So ZigBee, Wi-Fi, LTE in the same platform, in the same network. We have 6-low-band, we have wired, LTE. So if you see Bluetooth and LTE, so different technology in one IoT platform. For example, you can see this person is suffering from any blood or heart problems. So by using IoT, we will attach the sensor to his watch, to his belt, to his shoes. So all of these devices is called IoT device. Why? Because this smart watch can you connect to internet. Mobile can connect to internet. If you put sensor in the belt, it can be connected to internet. So all of this sensor will track his blood pressure, it will track his heart rate by using sensors, and then send data to the mobile. Mobile here is the processing stage. It will collect the data from these devices, and if any emergency data, it will send to the server or sent to the cloud or to the hospital, which can send the ambulance if there's an emergency. This is how IoT devices can save a lot of lives and make the people doing their life if they have any problem in health. Now, if we speak about IoT networks, as I said, we have Wi-Fi. Wi-Fi is our wireless local area network technology, which is based on IEEE 0.8.11 standards. So, Wi-Fi device. What's the meaning of Wi-Fi device? The device can called Wi-Fi device if it is can connect by through Wi-Fi. So, your smartphone use Wi-Fi? Yes. So, it's called Wi-Fi device. Smart device can use Wi-Fi? Yes. So, your smart device is called Wi-Fi device, as laptop, PC, and so on. What is the area? Wi-Fi can use in home area, school, computer, laboratory, office building. This is a suitable IoT network to connect devices to the gateway. So Wi-Fi device can have communication about 30 meters indoor. So what is about the bandwidth rate? In IEEE 0.111a, it can achieve up to 54 megabytes per second. If you ask about 11B, can achieve 11 megabytes per second. If you speak about 11AB, it is achieved to up to 7 gigabytes per second. Second network is Bluetooth. It is wireless personal area network, WPAN, because it is using in small distance. So what is the Bluetooth devices? Your mobile phone is Bluetooth devices also because your mobile support Bluetooth. Headset, how we can use it? We can use it in health, in heart monitoring, in medical equipment. Here, small distance and small bandwidth. It can cover to 10 meters till 50 meters. And the bandwidth, if we speak about Bluetooth 2, it is give you 2.1 megabyte per second. If we speak about Bluetooth 4, we can achieve up to 25 megabyte per second. So when we can use this one or this one, it is based on your application. Bluetooth consume low power, but Bluetooth can cover small area. Wi-Fi can cover big area and big bandwidth, but it is consume more power. So it is based on your application. You can use your different network. Now it is very fast introduction about Internet of Things. As we say, Internet of Things is application of Internet of Things, military, environmental. If you speak about our health care application. Now let's go to the, as I said, this is the scale. You can see number of devices, which is through the internet in 2020, it is reached to end of this year, it will become 50 billion things. See, all of these things, if you speak about, see, it is started from 0.5 billion and it will come to 50 billion end of this year. That's why studying of Internet of Things is very, very important. Now let's go to the challenge. Now, as I said, wireless sensing network is using in complex area. So in this complex area, how we can charge and how we can develop and tracking data from this area. If we speak also about integrating multi-communication technology as based on this photo, as I said before, and battery problem, it is the biggest problem, and security issue, and also how to support mobility, as I said. We will focus today how to reduce the energy consumption based on our title is IoT energy efficient scheme. Now, as I said, to solve the problem of power consumption or energy efficiency, these two parameters affect on the power consumption. We see distance and packet size. So distance, it is solved by using routing protocols. We will speak about routing protocols. Packet size, it can be solved by using the compression techniques. If we use compression techniques, we can reduce the packet size so we can extend the network lifetime. So in the compression technique, we will speak about compressive sensing. It is called, we have one topic, one is called so in compressive sensing is a new theory of sampling in many applications. Compressive sensing, it is appeared first time in 2007. And now it is very, very important and very sufficient application for data compression in more applications. For example, it is using in compressive imaging. It is also using in radar signal processing, biology application. So let's speak more details in about compressive sensing. As I said, this is a wireless network. This developed sensors is sensing data and sent to the base station. As I said before, the sensors consist of 5 units: sensing unit, memory unit, power unit, processing unit, and communication unit. Sense, I say that it will sense data, memory, it will store the data, and then this power unit is the most important unit. Now, instead of sensors send the data directly to the base station or to the server, as I said, from main GNU main gate to the computer science buildings, big distance. Instead to walk all of this distance, we will divide the distance. I will divide it. Instead of going from here to here, I will divide from gate main to KC, from KC to T point, from T point to T point, from T point to center. This is the simple idea of routing protocol. So of routing protocol, from routing protocol, you can see the sensor, instead of sensing all the sensors send the data to the base station, sensors select one cluster head, and then this cluster head will send to the another cluster head and then to the base station. So instead of sending data directly to the base station, routing protocol can solve the problem of the distance. Now, compressive sensing. As I said before, compressive sensing, it is now we can solve the problem of distance by using routing protocol. But routing protocol cannot be helped if we are speaking about big scale network, IoT. IoT, we are speaking about big data. So distance cannot be helped. We have also to solve the problem of packet size. So to solve the packet size, we are using compression technique, which is called compressive sensing. What's the difference between compressive sensing and traditional compression method? In the traditional compression method, the sensors will send the data and then will convert from analog to digital, and then we will take samples from this signal, and then finally we will receive the sample or the compressed signal. So from here to the compressed samples, we are going analog, digital, and then take sample, and then using compression technique, and finally we will receive the compressed samples. But in compressive sensing, we will sense, and after we sensing, we will do compression in one step. See, all of this stage is not used in compressive sensing. That's why compressive sensing is very strong. Instead of doing all of this intermediate stage, here, sense, after that, compress. In compressive sensing, we will sense and compress in one step. That's why compressive sensing is very important and very strong compression technique. What is the framework of CS? CS, we have one signal. This signal we can present in vector n by 1. So we have signal, we call it sparse signal. What's the meaning of sparse signal? Sparse signal means the signal which has big number of non-zeros values and non-zeros values. It's called sparse signal. So if I have these sparse signals, I can present it in vector n by 1, and then I will generate random matrix. This random matrix, it is called CS matrix phi. And this matrix is m multiply n. So I have vector n multiply 1, and I have matrix called CS matrix, it is m multiply n. Such that m is big small than n. So if you multiply this matrix, multiply by this vector, so m go by n, it will have n by 1. See, now you can reduce n, vector d, from n by 1 to vector y, n by 1 in one step. And this is the powerful of compressive sensing. So we can express the framework of compressive sensing as y equal phi. Phi is the compressive sensing matrix, and d is the sparse signal which we want to reduce. Now, I said D should be sparse. I cannot use compressive sensing in all data. The data should be sparse. Why? I will say why after some time. So, if we have two types, signal can be sparse by its natural, like this, you can see, come here. See, we have vector D. This red and green, blue are non-zeros, and white are zeros. This called sparse in its natural. So in this case, I can directly use compressive sensing. But if I have signal like this signal is non-sparse. Why? You can see there is no zeros values. So in this case, I cannot use compressive sensing direct. But for example, in wireless sensing network, we say the network, if I have sensors, I will deploy in area. So these sensors are near to each other. So for sure, there's correlation between the data. And if there is correlation between the data, for sure, there is data redundancy. So if I use any transformation domain, so in this transformation domain, it will convert signal from non-sparse by using the transformation domain. This data will become sparse. This transformation domain is like DCT or wavelet or Fourier transfer. So if I have signal D, this D is non-sparse, but I am sure this data has high correlation. So by using transformation, this data will be converted to sparse. Now this equation will be converted from y equal phi by d, because d is not sparse. I will remove d and I will put psi x. So the signal will be from d, it will be psi x. So from y equal phi d, it will equal y equal phi psi x, where psi x equal d. So y equal theta x, where theta is phi multiply phi. Phi multiply psi. Now, why it should be. Now, how to design? Now, all the idea of compressive sensing is based on CS matrix. CS matrix, I have vector, I will multiply by matrix, and then I will have another vector. How to design this matrix? To design this matrix, it is not easy task. It is a hard problem to design this CS matrix. Why? As I say, I have theta equal phi multiply psi. If we have this phi, CS matrix, and this is a transformation matrix, if the two matrices are high coherence means related, a lot of similar. If they are high coherence, for sure I can find two rows, one row equal one row, one column equal one row column, or we can see some zeros values here, some zeros values here. So when you multiply this one, this theta has no inverse if they are high coherence. And if it has no inverse, you cannot do reconstruction, because we have compression and reconstruction. So if I have y equal phi d, so d will equal y phi minus 1. If phi has no inverse, I cannot do reconstruction. So theta should be, the relation between phi and psi should be, has low coherence. Because if they have low coherence, now theta will not equal to 0, and this I can find solution. Now, why the signal should be sparse? Why the signal should be sparse? See, I told you from the framework, I want to reconstruct the framework, to come back to the framework. Y equal phi d. Y is n by 1, d is n by 1. And I said, if you come to this one, y is n by 1, y n by 1, d is n by 1. And phi is m multiply n, and m smaller than n. Here, if I want to reconstruct, in the reconstruction step, I have y and I have phi, and I want to reconstruct d. So d is n multiply 1, n multiply 1, and y is m multiply 1. So I want to reconstruct n from m. I want to reconstruct n from m, where m is smaller than n. So number of unknowns is bigger than number of inputs. Number of unknowns is bigger than number of elements, input. So it will be in the hard problem. But if it is sparse, now if it is sparse, I'm going to reconstruct
Hello, Ahmed sir, you are mute.
If I
Ahmed sir,
have,
you are on mute.
okay, sorry for that.
It's okay.
So if I want to reconstruct n from m, it will be difficult because n is bigger than n. But based on that the signal is sparse, now I want to reconstruct k from m. Why k? Because k is the non-zeros only. I am interested to reconstruct the non-zeros values only. So I want to reconstruct non-zeros value k from m, and k smaller than m, so it will be well posed and it can be solved easily. And to reconstruction, there's a lot of techniques to reconstruct. For example, confidence relaxation method and Grady algorithm. I will not go through this because time is run. Now, compressive sensing also can be used as an encryption method. Why? If it is y equal phi d, now d it is converted to y. So d converted from n multiply 1 to y m multiply 1. So if I will convert d to y, if y sent to the people, so y is not original data. So if hacker is there and he catch y, he cannot read the data if he don't have phi. So here we can consider d as a plain text, y is a ciphertext, and phi will work as a secret key. So compressive things also have a power to work as a compression and encryption method in the same time. This is the powerful of compressive sensing. Now, let's see how compressive sensing can work. If we will speak in compressive sensing has two ways. We have plain way and hybrid way. In plain way, we have these sensors. We have n equal to 12, n equal to 12, and it is divided in 3 clusters. In each cluster, we have cluster head, and we say m equal to 5. So base station, instead of collecting 12, it will collect only 5 based on compressive sensing. So if it is plain CS, the sensors will use the compression technique to compress the data here and here and here, here and here and here. So every compressive sensor will send m multiply 1, m multiply 1, m multiply 1. And then the cluster head will collect them in one vector, m multiply 1. And finally, the base station will collect m multiply 1. So instead of sending n multiply 1, 12, it will receive m multiply 1, which is equal 5. This is called plain CS. But the problem here in this way that the sensors, if the sensors data is less than m, if the sensors data is less than m, what will happen? Now I make them send more than m. If for example, if m equal to 5 and the sensor has only 2 bytes, and I make it send 5, now compressive sensing is not efficient. That's why another way is called hybrid CS. In hybrid CS, the cluster, the nodes will send the data without any compression. And the cluster head will sense that if the data he received from the sensors more than m, he will use compressive sensing. But if the cluster head receives data less than m, it will not compress. So in this case, see, d equal to 4, so 4 by 1, 4 multiply 1, 4 multiply, so no compression happened. So this is a problem of hybrid CS. In hybrid CS, sometimes the compression will not be happening. This is the case of the sensors don't have data more than m. To solve this problem, this is another algorithm called load balance. Load balance sensor, it is the main idea of this load balance, because time I have only 2-3 minutes. The idea of this, instead of I will make the clustering based on the m. So for example, here I have 3 clusters. So, and I want to make it 2 clusters, to make in each cluster number of sensor nodes equal to n. So this algorithm is called load balancing algorithm. In this load balancing algorithm, he takes the sensors and divides them to 2 clusters only to make compressive sensing efficiently work. Now, this is a compressive sensing. If I say, as I said, if we can look, I want to show you some small example. So if you will speak about compressive sensing, can you see this? Can you see
sir.
that?
Yes,
okay.
sir.
In compressive sensing, it can reduce the number of data transmission in wireless sensing network. It can also optimize the CS in wireless sensing network. It can also enhance the reconstruction process. Also, it can provide the security in wireless sensing network, IoT-based wireless sensing network. And this is the summary of our speak today. We spoke about IoT and how is IoT and how is IoT is working. What is the IoT layer? What is the IoT objective, and how we can use compressive sensing to improve the performance of energy efficiency. The last thing I want to share with you is I will show you one code. How is compressive sensing is working? Is it okay?
Hello.
Yes, yes. I am opening MATLAB. 1 minute.
Okay.
Now, come to this code. For example, here, you can see this?
Yes, sir.
Okay. So,
Sir,
for example,
can you zoom it a bit?
the problem Zoom is not working in my system. Sorry for that. Okay.
That's fine, sir.
Here, I told you if we are using compressive sensing, you can see this original seed. Okay. If I will run this, see what happened here. I want to show you before that. If we are using here, this is the original seed. One minute and finish. 1 minute. Okay.
No, you are talking about deltas?
Yeah, no. Jenny.
And you come to recommendation.
Yes. Okay, see, if here you see, I have it changes small things in compressive sensing. See, this is the seed of generating the compressive sensing matrix. If I change this seed with the small values, you can see I will run again. Sorry, because I have a class, so it will. Now see, it is see, this is the original data is the blue, and the reconstruction is the red. You can see if the Hackathon has the original CS matrix, he cannot reconstruct the data. See, the original is the blue one. The original data is the blue one, and the reconstructed data is the red one. If the compressive Hackathon has the original CS matrix, he can never reconstruct the original data. This is the simple way of using compressive sensing in a security way. So it is only simple example. Inshallah, in the more upcoming, we will do more breaks on that. So now I finished. Any question? Any question? Hello? Yes, sir.
Sakshi?
Yes, sir. Yes, sir. Participants, any question? Okay. Sir, you are going to take questions from the chat, or you're going to hear them?
Hello.
Yes,
Hello,
yes.
Ahmed, sir.
You can execute by yourself.
Hello.
Yes, sir.
Hello. Am I audible?
Yes, yes.
Sorry, sir. Sir, basically, I want to know that how much energy is used for sending some data over a small distance, say 1 meter wirelessly? Hello? Hello?
Ahmed sir?
Hello?
Hello.
Hello?
Am I audible?
Yes, sir, you are audible, I think. Ahmed sir.
Sir, your voice is quite low. Please speak bit louder, sir.
Hello? Hello?
Yes, now it is clear, sir. Please ask
Okay,
your
okay.
question, sir.
Emma sir, I want to know that how much energy is used for sending some data over a small distance, say 1 meter wirelessly, because in WSN there are so many sensors. One sensor is sending data to another sensor wirelessly. So let us say there are two sensors 1 meter apart, and one sensor is sending data to another, say 1 kb of data. So is there any standard definition, standard research paper or some statement somewhere that shows okay, that much of energy is used?
Hello. Good morning, sir. Hello.
Hello?
I think Ahmed sir is not here.
Hello. Ahmed, sir.
Okay.
I
Hello?
guess there's some network issue. Hello? I request the co-host to please mute the participants so that I can listen if Ahmed sir is speaking or not.
Hello?
Yes, Sakshi, you may continue. Continue. All the participants are in mute now.
Okay, okay. I think Ahmed sir, there's some network issue. He's unable to connect.
Yes, probably.
Okay, okay. So we'll share the Gmail ID so that participants can ask questions there. Sorry for
Okay.
the inconvenience. Okay, thank you, Ahmed sir, for such an informative session. Okay, so ma'am,
I
is
think
there
we
a...
will wait for a few minutes. Maybe he will
Okay,
rejoin.
okay, we can wait. Okay, okay.
Yes, just for a few minutes.
Okay, is Karan sir here?
Yes, sir.
I am here.
Okay, sir, I think Ahmed sir is
We
unable
will
to
wait
connect now.
a
Yeah.
minute, then we will break if he will not come back. Okay.
Okay, fine, sir.
Karan, sir?
Yes, ma'am, Sakshi here.
I think sir is not rejoining because
Okay,
there
ma'am,
is
so
no
we
one
can
in
have
between.
break so
There
that...
is a network problem, I think, because he
Okay,
is
sir.
not connecting on WhatsApp also.
Okay, sir. So
Yes,
I,
yes.
on behalf of the whole FDP team, thank you to Ahmed sir for such an informative session. So we can have break here so that we can start with the next session at 12.
Yeah, before time, everyone will be joining.
Okay, I request everyone to be there at 11:50. Thank you.
So, Sakshi? Sakshi?
Yes, sir.
Yes, sir. Yes,
Sir,
sir. I'm
Namaste,
here.
I think Adij is just coming. When he will come, then just
Okay, sir.
think if he will join.
Okay, sir.
If there is any question from participant, they may ask 1, 2, 3 question. Okay. If he
Okay,
join.
sir. Okay, sir.
I think there are so many participants who has raised their hand. So better they will post their questions in chat box so that once our speaker will join and they can answer one by one. It will be more better, I think. So participant, please post your questions in chat box.
Hello.
Hello. Yes, sir.
Jairuddin sir is in.
Okay,
Please.
sir. Okay.
Okay.
Yes, sir.
Okay, sir. I'll be starting at 12. It's 11:55 now.
सर से पूछो तो सर कहाँ है पहले?
Hello.
एक बार सर से बात कर
Okay,
ले।
Zairuddin sir is here. So he is on mute.
नहीं, सर को कोस्ट बना दिया मैंने।
हाँ जी सर.
एक मिनट अनम्यूट कर देते सर। अनम्यूट। अनम्यूट ही नहीं हो रहे सर।
हाँ?
अनम्यूट नहीं हो रहे।
अच्छा एक मिनट मैं करूं?
हाँ आप करिए सर।
वो भी हाँ। मैं भी कर रहा हूँ तो नहीं हो रहा। नहीं हो रहे? अब हो गए? हेलो
He is in, sir.
हेलो वीर साहब आवाज आ रही है?
हेलो।
हेलो हाँ आवाज आ रही है? गुड मॉर्निंग।
हाँ आपकी आ रही, मेरी पहुंच रही है?
बिल्कुल पहुंच रही, बहुत अच्छी आवाज आ रही है आपकी।
तब तो इसका मतलब ठीक है ना?
हाँ ठीक है, बस जरा वीडियो भी ऑन करिए एक मिनट।
हाँ सर।
हाँ बस
2 मिनट के लिए बाद में हो सकता है बोलने में अगर बैंडविड्थ ठीक होगी तो वीडियो ऑफ कर देंगे, पर अभी तो ऑन करिए।
हाँ
आवाज तो बहुत अच्छी आ रही है।
अच्छा। अरे लैब से कर रहे हैं यहाँ हमारे एहतशाम साहब के, अपने जामिया में आ गया हूँ, घर पे नहीं हूँ।
अच्छा अच्छा अच्छा, जरा वीडियो ऑन करिए। वीडियो
हैं?
वीडियो वीडियो।
हाँ हाँ जामिया आ गया हूँ डिपार्टमेंट में।
मैं कह रहा हूँ कि आपका ऑडियो तो अच्छा था, जरा वीडियो भी ऑन करिए।
वीडियो?
हाँ
अच्छा देखना कहाँ पे?
नीचे उसी ऑडियो के बगल में होगा।
हाँ हाँ
ऑडियो के राइट में ही है सर।
हैं?
जहाँ पर ऑडियो का सिंबल बना है ना, उसके बगल में वीडियो का भी सिंबल बना हुआ है। कैमरा नहीं है क्या इसमें? कैमरा होगा सिस्टम में।
अरे बहुत पुराना लैपटॉप है यार, इसलिए।
अच्छा कैमरा
हो सकता है कैमरा ना हो।
आ गया आ गया, ऑन हो गया
आ गया।
आ गया। थोड़ा धुंधला आ रहा है, थोड़ा थोड़ा अपनी तरफ लैपटॉप को थोड़ा आगे की अपनी तरफ झुकाइए।
पीछे वाली लाइट बंद कर दीजिए सर, तो
हाँ।
साफ आ जाएगा।
अच्छा
तो आपके चेहरे पे कहीं लाइट पड़ रही है जिससे वो थोड़ा लाइट कम कीजिए।
मुझे पीपीटी कनेक्ट करने का असल में ढंग नहीं था, तो मैं इसीलिए लैब में आ गया।
नहीं नहीं वो तो हो जाएगा, बट थोड़ा आपकी लाइट ज्यादा जल रही तो वो लाइट की वजह से पिक्चर साफ नहीं आ रही है।
अब पहुंच रही है मेरा?
नहीं पिक्चर तो आ रही है, बट आपके चेहरे के पास लाइट बहुत है तो वो पिक्चर धुंधली आ रही है।
अब कम हुई
ना लाइट? अब तो थोड़ा सा, अब तो अंधेरा हो गया। हाँ, अब ठीक है, अब बेटर है पहले से। हाँ।
अभी साफ नहीं मेरा ख्याल मेरी।
ना 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 साफ नहीं आ रही है।
जिधर लाइट है ना सर उधर को चेहरा करिए।
लाइट तो नहीं है उधर, तो बंद कर दिया है, लेकिन वो मेरा ख्याल से कैमरा बहुत खराब है इसका।
अब आ गया सर।
हाँ हाँ वही लग रहा है।
अब आई?
यस सर यस सर।
अब बढ़िया है। हाँ अब अच्छी आ रही है, अब साफ दिख रहा है।
हाँ असल में बहुत पुराना, ये 10 साल पुराना है लैपटॉप, जब वीडियो नहीं हुआ करता था।
पर फिर भी ओल्ड इज गोल्ड, ओल्ड इज गोल्ड हो रहा है।
हाँ पहले से कुछ साफ है। थोड़ा सा।
हाँ बेटर है पहले से।
कभी
हाँ
यूज नहीं किया ना असल में, इसलिए तो ऐसी
हाँ
मीटिंग में मोबाइल से कर लेता था। इसमें जामिया के 1-2 दिन हुई थी।
वो है ना कि हमें लगा कि धूल ये लैपटॉप पर है लेकिन कमरे में ही धूल है। ऐसा हो रहा
हाँ,
है।
तो बस तो मैं अभी आपका लेक्चर खत्म हो गया?
हमारा कल था।
अच्छा
आज दूसरा किसी का था, वो खत्म हो गया है।
अच्छा अच्छा अच्छा।
वो एक बाहर से था, पुराना जेएनयू का स्टूडेंट था लेकिन वो बाहर से था,
अच्छा अच्छा।
तो उसका था। आजकल ये सब ऑनलाइन ही हो रहा है।
हाँ यार, क्या बताया जाए, ऑनलाइन तो ऐसी मुसीबत बन गया है ये।
हम्म। पर इस तरह के लेक्चर देने के लिए ठीक है, क्लास के लिए तो नहीं है ये।
लेक्चर के लिए भी ज्यादा अच्छा नहीं, वो फिजिकल सही रहता है।
हाँ वो फेस टू फेस का तो कोई जवाब नहीं है।
हाँ, उसका कोई वो नहीं है, बढ़िया है।
तो दूसरा बात ये है कि ये काम चला रहा है।
हाँ, बस काम चालू है।
ये है।
चलो, पहला खत्म हो गया, दूसरा वो है आपका। हाँ?
आज का दूसरा है। हाँ।
कल शुरू किया संडे में?
कल शुरू किया था।
अच्छा,
हम्म
संडे के दिन।
हम्म।
जब मंडे तो 5 दिन, कितने दिन का हो जाएगा ये?
5 दिन।
तो क्या थर्सडे में खत्म करेंगे?
हाँ 4 तारीख को।
पूरा हाँ, ये सब। तो
स्टार्ट
तो है।
Okay, so shall I start?
पीपीटी आप
स्टार्ट कर सकते हैं।
आप जरा पीपीटी आप लगा लीजिए, पहले शेयर कर लीजिए थोड़ा, है ना।
हैं?
पीपीटी है।
हाँ, पीपीटी है।
हाँ जरा उसको लगाइए फिर।
पहले सर के बारे में थोड़ा बोल देते हैं सर।
हाँ जी सर, ओके।
हाँ ठीक है, आप बोल दीजिए। मैं कह रहा था ना, वो जरा मैं कह रहा हूँ लग जाए, उसमें टाइम खराब नहीं होगा ना, फिर इंट्रोडक्शन करने के बाद भी शुरू हो जाएगा। खाली वो कई बार होता है ना, शेयर नहीं हो पाती, तो एक बार देख लें, मैं ये कह रहा हूँ। हेलो।
हाँ,
Yes sir, okay sir.
वो फ्रंट पेज लगा देना। हाँ तो वो शेयर हो रही है कि हाँ हो रही है, शेयर हो रही है।
हाँ sir.
अच्छा।
बस आप
Okay sir.
हाँ, हो गया, ऐड हो
हाँ
गया।
हाँ बस अब इसको जरा इंट्रोड्यूस कराने दीजिए, उसके बाद आगे बढ़ेंगे।
Okay sir.
हाँ साक्षी शुरू
So
कर।
shall I start? Okay.
हाँ
So welcome back everyone.
अभी नहीं।
Since our
हाँ
what sir?
ठीक है, जहीर साहब से कह रहा था। अब तुम साक्षी शुरू करो।
Okay sir. Welcome back everyone. Since our previous speaker Dr. Ahmed was unable to join us back, so you can all mail him your queries later. Okay, I hope we are ready for the next session as our speaker has joined us. I welcome Dr. Zahiruddin as our speaker of this session. I would be delighted to give a brief introduction of Dr. Zahiruddin. Dr. Zahiruddin, you are currently professor in the Department of Electrical Engineering, Faculty of Engineering and Technology, Jamia Millia Islamia, New Delhi, since 2003. You were head of the Department of Electrical Engineering from 2011 to 2014. You attended Welix Engineers Development Course at Duncan, Oklahoma, USA. You were visiting researcher at the University of Missouri, Columbia, USA in 2003. You have published 80 research papers in international journals and conferences in the areas of soft computing, noise pollution, wireless sensor networks, optimization techniques, and smart grid. You are reviewer of many international journals of IEEE, Elsewhere, Springer, and ACTA Press. You have organized a short-term training program on MATLAB and soft computing sponsored by AICTE at Jamia Millia Islamia in 2004. You also organized a 2-day workshop on curriculum revision for BTech MTech courses in electrical engineering in 2012. You have contributed in the Department of Electrical Engineering by starting first QIP program in the Faculty of Engineering and Technology in 2016. This QIP program was approved on your proposal submitted to AICTE in 2011 as a coordinator. Another highly appreciable contribution to the department is to start a PG program leading to the award of the degree of Master of Technology in Control and Instrumentation Systems in the year 2012 as a founder coordinator. During your tenure as head, you also took initiation to get approved 5 BSR scholarship of UGC for full-time PhD scholars in the Department of Electrical Engineering in 2012. You received Indian National Science Academy Visiting Fellowship Award for the year 2004-2005 to work in Computational Intelligence Lab at Indian Statistical Institute, Kolkata. You are a fellow of IETE and life member of World Federation of Soft Computing USA, the Institution of Engineers, Computer Society of India, Indian Society for Technical Education, the Indian Science Congress Association, and Indian chapter of the International Center for Theoretical Physics. We are honored to have you join with us today, sir. I request you to proceed with your session. Over to you, Dr. Zahiruddin. Sir, Zahiruddin, sir, can you hear me?
हेलो
जय साहब आवाज आ रही है?
Yes, sir. So
हाँ।
please proceed with your session. Thank you,
आप
sir.
स्टार्ट करें?
हाँ आप शुरू करिए। अगर ऑडियो में कुछ गड़बड़ आएगा तो वीडियो ऑफ कर दीजिए बाद में। अगर ठीक चल रहा है तो ठीक है।
हाँ चल रहा है।
हाँ तब तो ठीक है। हाँ सही है अभी तो।
हाँ स्टार्ट करें लुबियाल साहब?
हाँ 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 बिल्कुल।
अच्छा अच्छा तो
हम अपना वीडियो ऑफ कर लेंगे अब अपना हम सुनेंगे बस।
गुड मॉर्निंग टू ऑल ऑफ यू। हाउ करण सिंह?
हाँ हाँ आवाज आ रही है।
अच्छा अच्छा तो
आप शुरू करिए।
my lecture is based on the fundamentals of the IoT. So I will just introduce the basics of the IoT, Internet of Things. So as all of you are aware that it basically consists of the two parts, Internet plus things. So initially the Internet was connecting the people to people. There is a screen.
It is visible, sir.
ये ऊपर एक आपका वो आता हो थोड़ा हटवा दीजिए। ये करण सिंह?
Yes, sir.
ये थोड़ा हटा दीजिए, ऊपर एक स्क्रीन आ रहा है आपका ये
एक मिनट
ये
Please move.
चेक करिए जरा।
ये ऊपर ऊपर ये है।
ऐसा करिए ना सर, एक बार बंद करके इसको दोबारा खोलिए।
हैं?
आप पीपीटी को क्लोज कर दीजिए एक बार, फिर
अच्छा हो
दोबारा
गया ठीक।
नहीं अभी भी आ रहा है।
फिर आ गया।
ये
तो
आप
it is basically the connection between people to people. So internet connects all the people, whereas so you can see here in the figure that the basic purpose of the internet is connecting only the people, but IoT is different from this, that internet IoT connects people to people, machine to machine, and various devices can be connected through the internet. And IoT requires the internet, but internet doesn't require the IoT. So I will just start because it is based on the IoT. So the first I will give a brief introduction how the internet. This is a chronology of the IoT. So because there were also the means of communication before the internet. Internet is basically the means of communication from person to person, or from person to machine, or machine to machine, and so on. So in the primitive age, the people were still using the means of communication that was smoke signal, drums beating, and so on. But the electrical or you can say electronic devices started in 1886. That was first a telegraph. That was the first means of communication through the medium. Second, in 1870, telephone. Then radio and television came into existence in 1880. Then in 1890, fax, and then finally in 1975, internet. So this was the just a brief introduction. So the next is the term internet was basically the first coined by three professors that in 1974. So it can be interpreted as the combination of the two, inter plus net, means network between between two devices. So internet can be defined as the global connection between computer networks that transmit data through TCP/IP. So the popularity of the internet basically grew slowly, and there are 4 steps that led to the development of the IoT. So first, 4 phases are first digitize access. So that laid the emphasis on the connectivity and connected people to email, web browser, and search. The digitization of the internet basically started at this point. Email, web browser, and search. Then it was used in the business. It laid the emphasis on the network economy. So it enabled the e-commerce, supply chain management, and so on. The next was digitization of the interaction. So it provided the internet and then digital access, digitized business, digital interaction, and then IoT. The final stage was the IoT. Then you can see how it started from internet to IoT. Pre-internet, it was human-to-human communication, that was fixed mobile and telephony, SMS. Then leading to this, some smart network were used, and then we reached to the internet of the content. That was based on www, that contains email, information, and internet, and so on. Then next, internet of services, that is web browser 2.0, then e-productivity and e-commerce. Then again, with the help of this, we move to another phase of the internet of the people, that social media, that is Skype, Facebook, YouTube, and so on. Again, then last phase was the internet of things, in which we are passing through, and this uses the smart data and ambient context. So this is the basic introduction from internet to IoT. IoT basically connects all the things, that is called the internet of things, and it is the connection of the things or objects or machines. So 3 terms are commonly used. It is the internet of things, or internet of objects, or internet of machines. Their examples are sensors, actuators, mobile phones, many devices, home appliances, and so on. So, but we interact through these devices via the internet. So internet is required basically in order to connect mind to mind, or mind to things, or things to things, or machine to machine, and so on. But internet is the basic requirement, and you can see that all the devices, whether human being or mobile, telephone, or laptop, or home appliances, or car, or laptop, and so on. So you can connect, these devices can be connected through the internet. So the internet is the main thing through which we can connect all the people. So there is a law for 15 years. That was given by some scientists. So law for new technology development. So if you observe, then in mainframe, the broad-based uses of the mainframe computer started in 1965, though it was developed in 1944, but it was not available to other people. So uh, on the mass scale, you can say, especially it was available in the universities, in the research center in 1965. That was called the mainframe computer. Then the age of the PC came in 1980, and then 1995 internet, and around 2010. Basically, the concept of internet came into existence in 2008, 2009. So it is written around 2010. So there is a gap of 15 years for the development of each technology. That is why it is called the law for new technology development, 15 years law. So the basic purpose of the IoT is means we can access any device at any time, at any place, and from anywhere, and by anyone. So these are the things which is given anytime, anything, and anywhere. So at any time means you may be on the move, or you may be outdoors or indoor. It may be the nights and daytime. So this is basically the time, any time. Anywhere means you may be outdoors, you may be indoors, or you may be on the move. Anything means the connection may be human to human. It may be human to things, or things to things. So you can see that it is a multi-dimensional concept of IoT, whereas internet it was not a multi-dimensional concept. So at any time, suppose you are on the car, you can access any device at your home, or you can talk to anybody. So this is the basic aim of the IoT, that is you can connect any people or any device anytime, at any time, or from anywhere. So this is the diagram. So now what is Internet of Things? So still there is not exact definition of the Internet of Things. Various definitions has been given by different people. So term Internet of Things, it was first coined by British entrepreneur Kevin Ashton with the context of the supply chain management. And this concept was given in MIT Auto ID Labs. So future of IoT that is connected is basically by RFID device. So radio frequency identification. So complete automation of data collection, this was one of the aim. And the first article about IT was published in 2004. And that was called Internet Zero. So Internet of Things, it is also called Internet of Objects. So this is referred to wireless network between objects. Usually the network will be wireless, such as in the household appliances. So similarly, there are WSIS 2005, another definition was given, that is short range mobiles with the array of additional gadgets, and that enables the new form of communication between things and between humans and between things themselves. WSIS stands for World Summit on Information Society. So that is standardizing the IoT basically. The World Summit on Information Society is 2005. And another definition was given. The term Internet has become to describe a number of technology and research that enable the Internet to reach out into from any physical objects. So the things having identities and virtual personalities operating in smart spaces using intelligent techniques that connect and communicate with the social society. So this definition was given in 2020, IoT 2020. IoT basically, it is, you can say it is an extension of the contemporary technology of the Internet of Services. So objects can be living things or non-living things. The global connectivity has been possible only because of some devices like the sensor, actuators, microcontroller, etc. As per the conceptual framework of 2020, this IoT can be written as in the form of the mathematical equation. IoT is equal to sensor plus network plus data plus services. So these are the four important components of the IoT. So sensor network, because it is related, because there is some confusion about the IoT and sensor network. So the distinction must be made between the sensor network, because sensor network consists of a number of nodes, which can be very high, and generally it is the communication between the various nodes is through the wireless communication. So this is the layer 1, layer 2, layer 3, layer 4, layer 5, layer 6. So these are the basic concept of the sensor networks. And sensor networks, basically you can say sensor networks generally exist without IoT, but IoT cannot exist without sensor network. So sensor network is the essential parts of the IoT. So in terms of the Venn diagram, the IoT is basically the intersection of the two technology, that is information technology and operational technology. So information technology assists secure connectivity of the data and gadgets for a smooth flow within the vicinity of an organization. Operational technology basically supervises devices and processes on physical systems. So intersection of the IT and OT is basically the IoT. So Internet of Things, it is sometimes it can be defined as the intersection of the two. Connection of the multiple visions, that is, you can see here, the internet oriented visions and things oriented visions and semantic oriented visions. Again, intersection of these three technology, that will give the Internet of the Things. So things oriented visions, various devices are again RFID, UID, and smart home, NFC, everyday objects, wireless sensor networks, and so on. Connectivity for anything and so on. And for internet oriented visions, these are the Internet of Web Things. And so it consists only three things, and whereas this semantic oriented network also consists various parts. So combination of these three intersection, first things oriented visions, internet oriented and semantic oriented vision, that gives the Internet of Things. These are the. So next, IoT growth. During 2000, basically there are, you find two colors. We start from 2002, then 10, 15, and 2020. So this azure color, this basically shows the things, whereas the brown color, this color, shows the number of people. So you can see in 2000, number of people were more in comparison to the number of things connected by the internet. Whereas in 2010, just after the introduction of the IoT in 2008, we see that the number of people are here around, in the next slide we will give the exact figure. So number of things, you can see it is now increasing. In 2015, there are more number of things as compared to the number of people. So the number of people are reducing and number of things are increasing in IoT in 2015. And it is assumed that by 2020, there will be 50 billion things connected together, whereas the number of people will be reduced. So connection of major IoT, it is predicted that up to 2020, from 2020 to 2030, connection of 7 billion of the people and 7 trillion things. So the number of people are reducing, whereas the number of things connected will be 7 trillion. The exact figure you can find in the next slide. First world population in 2003, it was 6.3 billion, and connected devices were only 500 million. So there is a big gap between billion and million. So connected devices per person, it was less than 0.08. So it is connected devices persons are basically very, very low. Whereas after 2008, more connected devices than the people. So in 2010, 6.8 billion people, world population you can say, are connected devices, 12.5 billion. So here the number of devices has increased tremendously from 2003 to 2010. And the connected devices per person is 1.8, or it is around 2. Similarly, in 2015, number of devices are again very, very high, and the connected devices are 25 billion. And then in 2020, the connected devices are in trillion, whereas the world population is still in billions. So you can see the growth of the IoT from within 15 years, not 15, but within 10 years, you can say within 10 years, the growth of IoT has tremendously increased from million to trillion. So trillion devices are connected now through the IoT device technology. So we see why the IoT devices are required. So dynamic dynamic control of industry and daily life. It also improves the resource utilization, better relationship between humans and the natural process, forming an intellectual entity by integrating human society and physical system. So these are the some reasons why the Internet of Things are basically required. Flexible configuration, universal transports and internet working, accessibility and usability, and this acts as a technological integrator. So IoT basically acts as a various technology are integrated together. So these are some important things due to which the IoT is becoming very, very, it is now becoming the necessity for the people. So IoT basically can be combined. It consists of the physical objects or things. It consists of a controller. Basically controller, you can say it is the brain of the IoT. Then it consists of the sensor, actuators, and the internet connections. So these are the 5 important components of the IoT which are connected together. So in a simple way, we can simply say IoT is basically the combination of these devices. So hardware and software required in the IoT. So some of the hardware which are required for IoT are basically remote dashboard, then control, server, routing or bridge device, and sensors. These devices manage key tasks and future technology. Then the system activations, action specifications, security, communication, and detection. So these devices basically support for specific goals and actions. IoT hardware. So these are the hardware requires some other hardware devices, other standard devices which are required basically in IoT are desktop, tablets, or laptop, which can be used because you can see the desktop that is considered to be still the most important components of the IoT through which we can do the control over the system and its settings. The tablet provides access to the key feature system in a way resembling the desktop, but it still the tablet cannot be used as compared to the desktop. Cell phone also allows up to some extent, and other key connected devices includes the like routers and switches and so on. So these are the hardware parts of the IoT, and then IoT software addresses basically the key areas of networking and action through platform and embedded systems and middleware. These individual and master applications are used for data collection, device integrations, application, and processes. They exploit the integration with the critical, for example, the ordering system, robotics, schedule processing in the execution of the related tasks. So similarly, what is the data collection? That is very important parts of the IoT software. This software manages sensing, measuring devices, data filtering, light data security, and other heavy data security. It uses certain protocols to aid sensing devices with real-time machine-to-machine networking. Then it collects data from the multiple devices and distribute it in accordance with these settings. It also works in reverse by distributing. The system eventually transmits all the collected data to central server. So the basic purpose of the data collection of the software. Similarly, device integration, it is another software components. So software supporting integration between the various devices, all system devices to be connected to the IoT system. It ensures the necessary cooperation between devices. These applications are the device technology of the IoT because it is not an IoT system only. They manage the various applications, protocols, and limitations of each device to allow communications. So this is the basic function of device integrations of components. Then real-time analytics, these applications take data through various devices and converts into viable devices for pattern for human analysis. They analyze information based on various technology design in order to perform automation that provide the data required by the industry. So these are the some of the software components. Then again, application and process extension. These are the other software components. These applications extend the real-time application system and software to allow a wide range of the system. They integrate predefined devices such for special purposes, such as allowing certain minimum engineering instruments access. It also supports improved productivity and data collections. Then IoT technology and protocols. IoT primarily exploits standard protocols and networking technology. However, the major enabling technology are RFID, NFC, low energy, and energy wireless system, low energy radio, and Wi-Fi dial. These are the technology that support the specific functions needed in IoT system. So, what is RFID? It is basically a radio frequency identification. So, radio frequency identification, it performs the energy and versatile options for doing some function, for example, bootstrapping and payments. RFID technology employs two-way connections, that is, it receives as well as transmits the signals. This allows us to integrate radios in various radio signals and thus add the word anything. So through the RFID, we can connect anything. RFID tags is a small microchip that is attached. So small components are that collects data. So this is the basically you can see the RFID device. Then near field community. This is the next technology. NFC consists of the communication protocol for electronic devices, typically the mobile phones and the standard devices. Low energy Bluetooth. This technology supports the low energy for IT function. So low energy Bluetooth, and then next is the low energy wireless. This technology replaces the most important aspects of IoT, though sensors and other elements are used over long periods. Communication sometimes remains in listening mode. So low energy wireless not only reduces the energy but also extends the life of the device. So basic purpose of the low energy wireless device is to reduce the power. Radio protocols, ZigBee, Z-Wave, and threads are the radio protocols for creating low rate private area networks. These technologies are low power but offer high throughput, unlike many similar options. This increases the power of a small local device networks without the typical cost. Then LTE, long-term evolution. A stands for advance. So the new technology is the long-term evolution LTE. And this delivers an important upgrade to LED technology by increasing the coverage, but also reducing its latency throughput. It gives IoT tremendous power through the various ranges, with its most significant application in vehicle or UAE, unmanned aerial vehicles. Wi-Fi direct or wireless fidelity network, while Wi-Fi direct eliminates the need for protocols and allows peer-to-peer connection with the speed of Wi-Fi but with the lower latency. Wi-Fi direct eliminates an element of a network that often bogs it down, and it does not compromise on the speed or throughput. So some of the important functions of the Wi-Fi direct. Then uh, there are integrated, we can start 4-layer model of the IoT. Then sensing, first layer will be sensing and identification through various devices. Then network constructions, that is communication devices, and then information processing, where the information will be processed, that is the third layer, and integrated application. So this is the 4-layer model. This is called the 4-layer model of IoT. Their applications, so we start from the lower sensing, identification, network constructions, information processing. So information processing can be, you can see, it may be by the human being, it may be by the device. Similarly, network construction through satellite or through the various, and integrated by the application in household, in road transport, in weather forecasting, and so on. So these are the 4-layer model of the IoT, which is one of the important components of the IoT, which is the object. Means the IoT, which is also called Internet of the Objects, or Internet of Things, or Internet of Machines. So object, smart object, it is the basic philosophy, because basically IoT is connection of the various objects. So object must be smart. So that is smart object, the first concept of the smart object was given by Marcelo Kalman and Daniel Kalman. They introduced the concept of smart object. An object is considered as small if it is capable of describing its own action, interaction. These objects have sensing, computation, and wirelessly both in short distance and long distance. So these are the smart objects, and then we will introduce smart objects about then you can see how the various components of the smart objects are connected together. So main four components we have introduced, that is the memory, sensor, CPU, and actuators. So what is the function of the sensor? Sensors used for sensing physical data like temperature, pressure, vibration, etc. Memory is used for storing the values, and then integrated units, that is again some total integrated units embedded into a device to make them smart objects. So integration of these will be the smart object. Similarly, CPU, it acquires, processes, and analyzes the data. It has control a variety of functions. Then actuators receives control signals and produces some response to the physical world. So there are some other devices which are connected to this. So smart object basically consists of the four main: memory, sensor, CPU, and actuators. So this then sensors. What is the sensor? As the name implies, sensors are used for sensing. Sensors embedded in the device help the smart objects in sensing and measuring the various parameters of the environment. A lot of sensors are available which are used to quantify, you can say, because the sensors are basically used to measure or filter the data. We get the filter data. Actuators are the complements to the sensors. It receives control signal and produces some response to the physical world. We can also say that the sensor sense and send, whereas actuators act and activate. So this is the basic difference: sensors and it sense and sense, whereas the actuators act and activate. So the relationship between the sensors and actuators, you can find the sensors and actuators. So sensors basically it senses the data, then it is converted into various digital form, then again it sends to the actuator, and then actions performed as required by the actuators. Then useful work is accomplished, then physical environment, and again it is sensed by. So there is a cyclic process between the sensor and actuators. That is why they are the complementary of each other, the sensors and actuators. So next is the memory. So as you know, the memory basically collects the data and it helps in storage of the data. This data is then used for analysis, computation, and for decision making. So this is the basic purpose of the memory. Processing unit, a smart object has a processing unit that is used for processing and analyzing the data that is obtained basically from the sensors or actuators. This type of processing unit is to be smart enough according to the needs, and it must work according to the needs and kind of processing to be used by the applications. Microcontroller, it is the most widely used processing unit due to its small size. The processing unit of IoT is basically the microcontroller, which is very small size, simplicity of programming, less power consumption, flexibility, and low cost. So these are the various reasons why microcontrollers are used as a processing unit in IoT. Small size, simplicity of programming, less power consumption, flexibility, and low cost. Then communication unit. All the smart objects need to communicate to each other for sharing of the information. This communication may take place through various smart objects or to the outside world. The communication can take place generally through wirelessly. Then power source. These components need power to operate. The different source from which we can get the power are batteries, solar power, wind power, and generally the main supply. The requirements of the power consumption according to the scenario are the switching between the active and passive device, accessibility, power source being used, area of application, information, etc. So various types of the power sources are used depending upon the application and according to the situation or place. Top industries for IoT application development and revenue generation. So where because the industry will not spend until unless it gives the profit. So IoT is application development and revenue generation where it can be used. So IoT can be used in smart grid, smart health, smart cities, smart industries, smart car, and so on. So it's a application you can we will give you one of the application like the application smart car. So you can see the smart car may be connected through the gateway by various devices. It may be connected internal Wi-Fi. Mobile. It may be connected through the satellite. So this gateway through which the driver or car can access through various devices. So one of the example of the transport smart car, you can see here because a network basically consists of a network communication without a vehicle cannot interact with this surrounding to provide the various information to the driver and about the local roads, weather, traffic conditions. So that makes enable the driver to take some decision. This may involve automatic activation of the this braking system or speed control via the fuel management system. Condition and event detection sensors are also used to maintain driver and passengers safety through the use of airbag and seat belt. Sensors for fatigue and mood monitoring based on the driving conditions, driver behavior, and facial indicators can interact to ensure safe driving by activating warning system or directly controlling the vehicle. So adoption of the IoT network in transportation system are one of the main application IoT in the smart car. Then smart creatures IoT enabled Roche North Carolina. It is North Carolina State University where they are using trying to make some IoT enabled Roche. So this can be used. But similarly, for smart grid, it is very complicated because the grids are connected through various devices. Because generally it is required that there should not be the failure of the electricity. So various types of the generating devices are connected together. For example, the main supply are nowadays non-renewable energy systems because as required, uh, especially in the remote areas where where the supply through the main grids it is very costly. So it is better option to use some other non-renewable technologies such as solar systems or wind turbine systems or other form of the generation energy system. So they all can be connected together according to the needs of the people. So and they fulfill the requirements of the remote areas using so because in the remote areas the consumption of the electricity is very suppose in the hilly areas there is no requirement of the AC even in the fine is not required but so the requirement of the electricity is very low therefore we can generate the electricity through the non-renewable sources. So and they can also use the smart appliances. So smart grid main application of the IoT is it has found really a big revolution in the smart grid. Similarly, smart home. So in the smart home, you can use some sensor in the security camera. You can use security camera, blinds, thermostatum in order to maintain temperature of the house, speakers, locks that also can be attached through your mobile. So IoT means different uh, devices. Locks will be connected through the internet to your mobile or security camera you can see from anywhere about this device IoT. So you can check or you can ensure about the security of your home or when suppose there is a light and you want to use automatic blinds according to the uh, lights. So temperature can automatically be maintained. Suppose you are in the office and you immediately want you are coming from the office to the home, so you can on the AC if there is a hot season from there to the home or other devices like the fan and AC, fridge, TV. So these devices, suppose you have forgotten to switch off the TV or fans, then you can switch off through your mobile using IoT technology from the office. So these are the various applications of the IoT in the smartphone. Similarly, through IoT, if everybody is having IoT, then there will be less chance of accident through this using IoT technology because generally the accident occurs at the main points where sometimes the people don't care about the vehicle coming from other side. So through the IoT, we can reduce the number of accidents also. So connected factory. So factory can also be connected because any factory it may be having various offices in different locations. So different locations and in real time they can interact in the real time. People or management sitting in different parts of the country or in different parts of the world. Or they can also check the what is the demand of the and what is the product which have been basically product which are produced and suppose there is more demand then they can order immediately to produce more number of products in the factory sitting anywhere at any place and from anywhere. So these are basically the applications of IoT in factory and automatically they will be knowing how much anybody can access whether especially from the people from the factory. Okay, what type of the product is not there and how much product has been sold out and how much is demand. So they can manage according to the needs of the market and according to the, they can also know the prices. So these are the various factors which industry people can use through the IoT. So smart lighting, that is also one of the, so tunable light means you can use tunable light, 6 million colors activated by smartphone or over ZigBee, can serve as alarm clock, can synchronize colors to movies and possibly. So even the Philips, they have never thought that there will be so many colors produced using the IoT. So according to your needs, you can produce different colors and of different intensity. So depending on your choice. So this is one of the applications. Similarly, yeah, so business web. Similarly, in the business web is a cloud-based business environment that provides access to the necessary infrastructure, application, content, and so on. So this is end-to-end business. So this is a provider, basically, business web partner, service provider, developer community, business and enterprises and government. Then enterprise web of the machine data, then end-to-end and business web, then application, government connected consumers. So provider and where the users, you can say application means user, connected consumers through the business web. So IoT, it is playing a very big role in the business web. Internet of the battlefield, it can also be used in the battlefield, video camera, and infrared camera, microphones, and so on. So IoT has really got a application now everywhere you can see. So more smart. So these are where some application, and you can also get a smart bathroom, cabinet for medicine, smart refrigerator, smart toilets, smart history in museum, smart health, sensors in running, smart buying, smart shirt, smart helmet. So augmenting life with new things. So everything you find that becoming smart. So smart home, waste management, smart building, smart society, smart care, smart IT and communication, smart mobility, smart generation of the electricity, and so on. So you will find IoT application. Now, using the smart objects, you can see that it is changing. The IoT is now changing our life, and it can be applied to, or it can be augmented. IoT can be augmented with the life. So these are the various applications, or you can say the IoT. One of the important applications you can also use fight poverty. Try to get more shoppers from the Warden Road to Dharavi in Bombay. So this can also be used to, because through the IoT you can connect very costly area to the Dharavi in Bombay, that is nowadays it has become very popular due to Corona. So but generally the poor people are living in around many lakh people are living in Dharavi. So IoT can also be used for the poor people. That is one of the main applications. So IoT challenges, basically IoT issues and challenges. One of the main issues is attack. So information can be stolen or it can disrupt services. So there must be some control for smart door locks and lighting system that can be vulnerable. So malware infested refrigerators have sent spam door locks. So steal information or take control and disrupt services. So these are the various issues which has to be addressed by the IoT. So there are, because the information is available easily, then it can be hacked by anybody. Any hacker can steal your information. So there must be some protection devices and these IoT issues and solutions. So how to convince users that IoT technology protect your data and privacy. So the potential solutions for this are legal and regulatory. There must be the technical control also, and social ethics is also one of the potential solution, and market self-regulations. So these are the solutions of the potential solution, you can say, of the IoT issues and challenges. So generally, the technical control, it is more important as compared to the other people generally don't follow the social ethics and market self-regulation up to some extent. After technical control, the legal and regulatory, that will be the next potential solution for the IoT issues and solutions. Then IoT advantages, improve customer engagement. So IoT basically completely transform action from the customer point of view. So it has become more effective engagement with the audience through the IoT because anytime the customer can be connected to the provider. So it will help to improve the customer engagement. Similarly, it will also help in technology optimize. The same technology which are used for customer experience also improve the aid in more potent improvement to technology. IoT unlocks a world of critical functional and field data. So technology optimization uh, for, and improved customer engagement, and third is the reduced waste. Current analytics give the superficial waste, so that provide the real world information. So a lot of information will not be very useful. So this will also IoT, through IoT we can reduce the waste that is in redundant information. Enhanced data collection. Modern data collection suffers from the actual data. So IoT breaks it out of those spaces and where humans really want to go to analyze our world. It allows an accurate picture of reality. So these are some of the advantages of the IoTs, and other disadvantages of IoT are, though IoT delivers an impressive set of benefits, it also presents a significant set of challenges. Security, which I have already discussed, then privacy, that is the same thing. Advantages are, you can simply say it is an issue because IT creates an ecosystem which connects various communication over the network. The system offers little control design. This leaves user exposed to hackers. This you are at any time you are exposed to the attackers. So privacy, this sophistication of IT provides substantial personal data in extreme detail without the user's active participation. Then complexity. Some find IoT system very complicated in the deployment and maintenance, and because it also uses it is integration of the multiple technology, and a large section of the people are also using the various technologies. So system IoT becomes basically very complex. So, and flexibility, many are concerned about the flexibility of the system because various technology are integrated together. So they worry about finding themselves with several conflicting and locked systems. And another is the compliance disadvantage. IoT, like any other technology, basically incorporate business must comply with the regulations. So it is not necessary that all the people will be complying the business ethics. Its complexity makes the issue of the incredibility challenging when many consumers are software compliance is there. So IoT World Forum standardized architecture. So because there is still not a standardized architecture of the IoT, so first it is now proposed architecture. Till now, it is the current standardized architecture, that is the physical devices and controller. Second is the connectivity. So physical devices and controller, that is basically the things in IoT. These are the physical devices. You can say any objects in the IoT. It may be the humans, it may be the computer, it may be any smart device. Connectivity, communications and processing units. Then edge or fog computing, data element analysis and transformation. Then data accumulation, that is basically the storage, data abstraction, access and aggregation. Then applications, reporting, analytics and control. Then collaboration and processes that involve the people and processes. Then security, and these are physical devices. They are basically the secure content, silicon, secure network, and secure communication. Then secure data accumulation. Data should not be stolen. The secure storage and authentication, authorization, and identification of the malware. And finally, it is the application of the
Hello.
thank you.
Okay, so you are going to take up the questions. Participants, if you have any question, please raise your hand. If anyone is having any question, please raise your hand. Okay, so okay. Mr. Raju, I request the co-host to unmute.
Hello, sir. Hello, sir. Hello. Dr. Jahiruddin, sir.
Voice is not visible.
Hello.
Actually. Your voice is not clear.
Dr. Jahiruddin, sir.
Can you speak?
Mr. Raju, please ask your question.
Sir, am I audible, sir?
Yeah. You ask your question.
Sir, actually, I have one doubt, sir. For IoT, a particular architecture is there. Hello.
Sir, can you write your question in the chat box so that I can read it?
Okay, sure.
Because your voice is not audible. Okay, thank you so much.
Okay.
You can ask question through mail. You can mail me.
Okay, so there is one question in the chat box. Is there any sensor to detect locust?
Huh? What question?
Is there any sensor to detect locust?
Is there any sensor to detect?
Sir, locust.
जो आजकल ये टिड्डियां आ रही है उसकी बात हो रही है. जो ये टिड्डियों का अटैक हो रहा है ना उस पर पूछना कि सेंसर टू.
नहीं यार आवाज साफ है नहीं, पता नहीं उधर से बड़ी गड़बड़ आपकी आ रही है. मेरी पहुंच रही सही है.
नहीं, आपके साइड से थोड़ा कट कट के आ रही है।
हाँ वही कुछ गड़बड़ हो रहा है ना। चलो आप दे देना आंसर मेरी तरफ से। तो फिनिश करें।
हाँ और
Okay, sir. Agar participants, if you have any question, you can mail sir. Sir, Mr. Raju, so he is asking the question: is there any particular complete IoT architecture for agriculture?
No, see, architecture is not for agriculture or any specific application. These are applications. Architecture will be for a system like your IoT system. Whether you run an agriculture application, you run any other application, that is altogether different. Right? Architectures are not application specific, never application specific.
Okay, sir. So shall I take up more questions?
देखिए वहां तक आवाज जा नहीं पा रही, शायद आज कुछ गड़बड़ है नेट में पूरा। आवाज आ रही है सर?
So I think there's some network issue.
हाँ, तो खत्म कर दो फिर, हम क्वेश्चन इधर ले लेंगे जो भी होंगे।
Okay, sir. Okay. So thank you so much, Dr. Zahiruddin, for blessing us all with your knowledge. I would now request Professor Lobial to extend a warm vote of thanks to our honorable speaker, Dr. Zahiruddin.
Okay,
Lobial, sir, over to you.
Yeah. Thank you. I've heard it. And on behalf of the entire organizing team, as well as JNU, as well as School of Computer System Sciences, I am grateful, thankful to for agreeing to deliver a lecture aspect of IoT, how even from basic design of sensors to what you call the security and the privacy, all aspect of the IoT being covered. It's a thorough basic introductory lecture on IoT. Probably it could have been yesterday much better because it should have started. But nevertheless, it has a long coverage. And thank you Jahid Sahab for agreeing, and your friend all the time ready for help us. Thank you very much.
इसीलिए फिजिकल प्रेजेंटेशन ही सही होता है ना।
हाँ, इसमें कुछ गड़बड़ होता है।
क्वेश्चन ही नहीं समझ में आ रहा, क्या फायदा इसका।
हाँ,
वहाँ रहे कम से कम तो जो भी है सामने।
हाँ, नहीं फेस टू फेस का तो कोई दूसरा सब्स्टिट्यूट है ही नहीं।
ठीक है फिर।
ठीक है, ओके भाई।
Thank you so much, sir. Okay, Lobial sir, so we are going to end the session now.
अभी करंट
1:15.
1:15 हो गया?
टाइम तो हो गया सर।
हाँ तो खत्म कर लेते हैं और
2:30 पे ज्वाइन कर लेंगे दोबारा।
हाँ ओके, जल्दी आ जाए, थोड़ा 2:15 पे आ जाए पार्टिसिपेंट्स होते हैं।
यस सर।
Okay, so we can now have a break here. We'll begin the next session at 2:30. So I request everyone to join us back by 2:15. Thank you. Okay, it's fine. It's visible, sir.
Now, are you able to see the slides?
Yes, sir. Yes, sir. It's fine.
Okay. So, can I begin?
Yes, sir.
Okay. Good afternoon, everybody. And I hope all people are listening to me, because here it is one directional. I'm not able to see anybody.
Yes, sir. Everything is fine. You can.
Everything is fine. Okay.
Yes,
May I know your good name, madam? Who are you? Who are coordinating this presentation?
Sir, I'm Sakshi.
Yeah, Sakshi, in case you find any problem during the presentation, maybe you can call me on my number. I have already shared on the chat. Maybe we can see, because here it is, I'm able to see only my slides. I'm not able to see the audience or anybody else. So maybe it is one directional flow.
Sure, sir. I'll be contacting you in that
Yeah.
case.
Good afternoon, everybody. I'm Arvind Dixit. I'm representing a company called Advanced Tech India Private Limited. And by the request of Dr. Karan, sir, he has requested me that we can share industrial approach of IoT towards the faculty members. And since nowadays, you know, because of COVID-19, everything is getting online, whether it is work from home or anything, it has to be online. But IoT is not started now. IoT is from a long time back. And we are basically a electronics system design company. We manufacture a lot of electronic equipments. These equipments are especially used for different applications like agriculture automation, like process automation, like defense electronics, like biomedical electronics. But the background of the company and the background of our knowledge spectrum is a combination of embedded system, programming, software, cloud computing, and other aspects of engineering. From here, I would like to share the presentation of mine will be comprising 2-3 different scenarios. During the first few slides, you will come to know who we are, what we do, and so that this will set up the presentation scenario to you to understand, okay, what this company is about. And then in the second phase, we will move towards the real technology, what all IoT constitutes, what are the different components. Maybe some of the people in the faculty must be knowing many things, but if you know something, it is okay. If you do not know something, maybe I can help to share. And if you have any query, at the end of my presentation, you can have my email ID and you can share me your queries, because doing this kind of presentation where I'm not able to see the audience, maybe you will find something missing also. But it does not matter. You can share me your queries and other things. We are also trying to show you some real-time examples also, real-time equipments also, so that you know, okay, how this real-time IoT gateways looks like, how this real-time IoT sensors are interfaced, how this real-time IoT web applications are designed, and the overall picture of IoT-based application. So during my discussion with Dr. Karan sir, we have shared, okay, my presentation is not a mere theoretical presentation. It will share many case studies which we have already implemented. So maybe you will see, okay, what applications we have solved using IoT, and what is the business size of IoT, and how you, your students, your researchers can see this potential and can work into the IoT domain, because applications are enormous applications. You think of application, you will find IoT sitting in one part of the project. So here I will begin with, so you see, this slide will have various things you will see. So you will see this, so this is what is our company profile. As I shared earlier, the company profile is primarily an electronics manufacturing unit, but since electronics cannot work without computer science or artificial intelligence or the complete solution, so you will see that being a core electronics company, being a core manufacturing company, we have moved from this area of advanced platforms, which comprises of embedded systems, FPGA, wireless. Earlier, these things used to work in a different domain, but now they need to work in hand together. And then you will have a software development team with have a cloud and Android apps and web services kind of application. And then you finally package them and the final solutions comes out. So as shared, we work in primarily in these 4 or 5 business domain. One of them is defense application, agriculture, environment, and biomedical. And then we have IoT based automation solution. So these are some of the areas. We also work in technical education also, but these are the major areas where most of my IoT applications are designed. As you will see this slide, which will have a building automation, then you have environmental and agri automation, you have a defense automation, and biomedical automation. So these are some of the areas where a lot of automation solutions are shown, and different application case studies are being designed and shown to you. Some of our projects which we have done using using these kind of technologies are also shown here. So we have done applications on DRDO. Defense is our major client. Then we have done a lot of solutions for PSUs, and most of the slides which you will see that there will be a wireless connectivity. So this wireless connectivity is a very important part, which you will see in all of the products. You will find a wireless connectivity showing here. So this wireless connectivity means that this device acts as a controller, which will have a sensor input. And once the sensor is connected to this device, the data is being transferred from this wireless mechanism to the main controller, and from main controller goes to the cloud, and so the whole application moves around. So the major components which in any IoT system will comprise is it has to be either wireless communication or a wired communication. Now, I will go in detail, okay, what type of wireless communication and what type of wired communications are being used in IoT nodes. But here you will have a glimpse of seeing the different products, like early warning system for dam measurements. There are large dams which releases water into the rivers and canals, and those river canals, when they release the water, it makes sure that they generate a warning alarm. And warning is in the form of audio or video or audio visual or some kind of alert system. So this happens only when the whole system is connected through wireless mechanism. So you will see there a lot of different applications related to wireless sensor based building health monitoring. So if you have any building coming up, so all the buildings are connected to cloud, and from there you can see, okay, how the health of the building, like if there are any kind of seepage or there kind of any kind of vibration or there kind of any kind of temperature or other properties which need to be monitored can be done using this kind of system. So you will see there are different applications. These applications we have designed for a biomedical application where special anesthesia cases where such kind of sensors are connected, and through these gloves, the kind of pressure being exerted here is being transferred to the doctor's mobile or doctor's display. So these are some of the devices which we have done. And the technology behind all these things are sensors and the signal measurement. So any IoT system you consist of, you will find the very important part is sensors and the signal measurement. I don't know whether the faculty or the participants who are attending this presentation are a mix of electronics or computers or IT, but these sensors is a very crucial role. And so sensors have analog sensors or digital sensors or serial communication or any kind of communication which can be transferred using this kind of technology. Then we have Android based applications. So any data which goes to the web applications will be finally monitored using a mobile app kind of application. So this is another area where you will find a lot of information which is being fetched from the cloud on a mobile application kind of system. So these some of our technical strength on which we work here, and we'll show you some video also and some real-time products also, which is used as IoT gateways. This is another part where you will see the designing a solution, whether it is IoT gateway or anything, is a combination of all these components which are connected together. And out of these components, you will see there are sensors and there are actuators and there are electromechanics and everything. So this part becomes this middle part, which is going to be conclusion of all the parts are going to be used as a IoT gateway or mechatronics or automation solution, which will have some part is a microcomputer, system simulation, system analysis, sensors and other things. You will see that we have designed some kind of wearable biosuit. So this biosuit is a classic example which is being used by defense people, where body parameters like ECG, like body posture, like temperature, like blood pressure, like heartbeat, like SpO2 and other parts are being monitored, and they are being kept in a local unit, from where they are being transferred to the cloud-based application, where you know a person who is mobile and how is his health is being monitored. So this is a project which we have recently completed using a DST. This is a Department of Science Technology granted project, where we have done this with IIT Ropar as our academic partner. And this is the first version which we have designed, and the later on versions are going to be different. And similarly, you will see the other applications like these kind of suits are going to be there, where the thermal and textile is going to be designed in such a fashion that they will glow like anything. And so this is not going to be a part of a wearable biosuit. We are also working in automatic weather station, air quality monitoring station, water quality monitoring station, and other issues. But the good part you will find is why I'm sharing these different applications, that you will understand, okay, what is the application of automatic weather stations in IoT, how the air quality monitoring station are going to be playing a role, and what is the IoT role into the air quality monitoring station, what is the IoT role into the water quality monitoring station, and how a real output can be monitored by applying IoT into these different applications. So when we say about automation, again, we say about sensors, signal conditioning, data logging solution, software and cloud-based applications, mobile apps industry applications, which are being used for predictive maintenance. Now, this is the area where more and more industries are using IoT for predictive maintenance. It is not for preventive maintenance. It is also used for predictive maintenance. Under predictive maintenance, we have recently done a project in a company called TVS Motors. So they have used different motors, and their motors are connected to the IoT gateways, and then their entire current consumption, vibration, temperature of the windings, everything is being logged. And using a data acquisition kind of system, the data is being transferred from using a Wi-Fi protocol to a local server. And on a local server, they are using analytical applications to identify, okay, during the very first day of the month and during the last day of the month, how this motor parameters are being monitored, and whether the motor is going to burn or whether the motor is going to work in a higher vibration, or the temperature of the motor goes increasing in the later part of the day. So such kind of predictive maintenance kind of applications are being designed using this kind of system. This slide will do that, and then we will do this, and so here, we are doing online data information from where anywhere to main control station, which is being used for knowing the status of machines, breakdowns, production, and maintenance. And using IoT kind of app-based design, We are designing mobile terminal based data monitoring facilities. So most of the information is available on handsets with real-time analytics, artificial intelligence. So the real IoT in industrial term is to get the data onto a server and then analyze the data so that the machine can take a action on that. So this is where you will see. So this is a part of analysis, reporting facility for the automated cloud-based data application. So this is the same slide which I have shared. So you will see there are part of sensors. So there could be different sensors and different signal conditioner. So IoT gateway defines, okay, how many sensors you want to connect to a IoT gateway, and whether these sensors are ready to use sensors, or you need to make a signal conditioner for those sensors. So this is where you will find, identify the sensor and the signal conditioner. Then the power supply, what type of power supply you are going to use? Are you going to use a solar or a battery or a main, or what kind of power supply you are planning for the IoT gateway? Data logging. So this data logging and local storage. But what samples you want to store the data? Do you want one sample a day, or you want one sample a minute, or you want to have one sample a second? Depending upon your real requirement, you can plan this, and then you can transfer data to cloud-based web applications. Now, how this data is going to be transferred from cloud-based? So the different mechanism, which could be a Wi-Fi based, or it could be a LoRa based, or it could be a GPRS based, or could be a LAN based. So different mechanism plays a very bigger role when the data transfer happens for cloud based web applications. So data transfer, once you have logged the data gets transferred to the cloud for web application. Then comes data analytics and API libraries database. So we will show you some mobile app where this we have designed API libraries and data analytics. Once the data comes to my web application, I can use either the web application or using my mobile device, or I can share this application with other third-party companies using my API libraries. Where other important thing is database, how this database is going to be designed, what kind of SQL server or other databases are going to be created, and how this data communication can happen. So this is a very important part where you have sensors, you have connected the signal, you have connected a power supply, it is very important, sir. Then you have a data logging, local storage, data transfer to the cloud for web applications, data analytics, API libraries, another thing. Very important part comes with the control actuation libraries. Suppose we are using a device which has some kind of threshold input, and based on those threshold input, the system need to shut some applications or shut down some control IOs. So these are some of the control application libraries which comes as a part of the IoT gateway, and then you can control any actuations. This mobile apps for visualization is a very important part, because nobody is going to be near to the computer every time. So they need to have a mobile app which they can use for visualization. They can also use it for data trending, data analytics, some kind of, there are many applications which people can use for. As I shared, different sensors like air, water, environment, agri-processing, smart industry sensors like temperature, humidity, process sensors like load, force, torque, power, or many other things. IoT applications for agri-processing, which I'm going to share in my next slide, and food processing applications, and many other such requirement, which is based on sensing. So this is one application which I will share you. This is an IoT based application in agriculture. This is the application which you will see here on a mobile app, that different parameters like soil moisture. plays a very important role. Soil conductivity plays an important role. Soil temperature. So then you have a NPK sensor. This is potassium, this is sodium, and there's other sensors which need to be there. Then the soil pH is a very important role. So once you install these sensors in a real-time field, you will see the whole system is used for precision irrigation, for proper water conservation and good plant growth. So how this happens, this is a project which we have recently done with IIT Kharagpur for one of their applications for smart industrial application, smart agriculture application in Department of Agriculture. So they have used different sensors on a larger field, and they have used a irrigation pump, and they have monitored, okay, with what kind of condition, what kind of pumping system need to be done, and what is the growth of the plants over here, and during one season, how much precision output they have been able to reach. So this is another application. So where they have used different analytics. Okay, if during summer or during winters or during rainy season, how the soil behaves, and for what particular crop, how the soil behaves, and if any particular crop requires more water or any crop requires less water, or they need to have a more fertilizer, or they need to have a more proper shielding from the temperature or humidity. So this is where we have used these sensors, and the whole system has been designed using a mobile app and other things. Other environmental sensors you will see. So this is a standalone. This is a standalone kind of a system where you will see this is a solar panel, and some kind of sensors are connected. What are those sensors connected is the temperature, wind speed, wind direction, relative humidity, solar radiation, rainfall, pressure, leaf wetness, and other sensors. So this is a device which acts like a standalone IoT solution, which will collect the data, and then the data is transferred to the cloud using a wireless GPRS mechanism. So a lot of applications are there where there is no human intervention, there is no person sitting collecting the data. The data is being collected by the machine and is being transferred to the cloud, and from anywhere to anywhere a person can visualize the data. So how it happens, so here you have a mobile apps kind of thing. You will see here different readings also, like at what particular time, at what particular date, what is the reading which were there. And based on this database, we can definitely work it out about the probability of or future prediction of weather in a different environment. So this is a product which, for future predictability, you need to have data, and for the data you need to have a data logging system, and for data logging system you need to have a sensor, and once the data is logged, the data is logged at the cloud. And so most of the applications, web applications which are being designed, are designed on a cloud-based application, or what we also know them as a web applications. So this is an example of what is the air pressure, soil moisture, ultraviolet radiation, rainfall, and other things. So here you will see we are using a lot of such kind of data loggers or IoT gateways which are being used here, and one of them is installed in Chandigarh, one is installed in Panchkula, in Mohali, or some other places. And this is where they are logging the data, and once the data is logged here, our data machine learning guys and artificial intelligence developer guys, they use this data and then they design algorithm for future production. So you will see This is how the cloud-based applications are being designed. Now, how this application is designed is using different Java or Python-based applications, which we will also share. And but this is where you will see. So you have a reading which you can download it from the CSV format, and then you have mobile apps, and then you have environmental sensors, and then you have this kind of application. So it just starts from here, like what are the different types of sensors which are going to be used, how the data logging is going to be used, how the data transfer for the cloud-based applications is used, and how data analytics and API libraries are being used, and how this control and actuation libraries, you see this control and actuation library. So you go ahead, you will see once the data is logged, so the different sprinklers which are placed all across the places, they act as a device for actuation. So again, there's no human involvement. The system designs based on the parameters, how much water need to be supplied, which valve to be opened, which valve to be closed, which plant needs what water, which plant needs what kind of health treatment based on the system, and everything is automated. There is absolutely no person involvement. Person's involvement is when they see, okay, some kind of system is giving the wrong data, then only they go and see the data. So these are some of the applications which you will see for the cloud readings. And here I will close my first presentation, and I will open another presentation which will have more information, and where we will show you the real time of IoT loggers and gateway. So here I will take a small break, and can I speak to the organizer again?
Yeah,
Yes, sir.
please, Albin.
Hello, may I know whom I'm speaking to?
I'm DK Lobial, one of the coordinators of this FDP.
Okay, yeah, Mr. L'Oreal.
Lobial.
Okay. Sorry for
No problem, no issue.
So my idea is what basically the whole theme is of IoT. I have tried to show them, and my another presentation which will also have some information, and then we will go for the real-time programming or real-time solutions. So in case any question comes, maybe you can speak to me right now, or maybe you can note down my email ID, which is given here. So you can note down this email ID, and you in future, in case of other information, maybe we can share with the organizers who can further transfer this data to the participants.
Arvind, may I request one thing?
Sure.
Yeah, see, if you want to have a break, and then we'll start next session. Towards the end, if 10 minutes, if you can have question answering session towards the end, that will be much better.
Mr. Lobial.
Yeah, please. Hello, yeah. Am I audible?
Yeah, I got your point. We will take a 5 minutes break, then we'll begin with second presentation, and then we will show you the live experimentation also.
Yeah, true.
And since there may be some expectations from the faculty members or the participants, they want to know something more, or they want to know something different. Maybe they can prepare their questions on the during this whole presentation, which I would like to address at the end. And in case I'm not able to answer it today, maybe tomorrow I can reply them at any given moment of time. But we'll try to do it we will try to close it by today itself.
Yeah, sure. Thank you. That's so nice of you.
Thank you, sir. Thank you.
We will also take questions on the chat. They are also sending questions, so we'll take care of that.
Okay, we'll see the chat, and we'll try to show some more things.
Yeah, sure. Please take a break. Yeah.
Thank you.
Sakshi?
Yes, sir.
हाँ तो 5-7 मिनट का ब्रेक जो भी है, ठीक है ना?
Okay, sir. Okay.
Participant
have
can also
here-
have tea at home. हेलो संजय, हेलो श्रेया।
आपस में बात कर रहे हैं।
Hello, Sakshi?
Yes, sir.
से पूछे या
Okay, so he is here.
या
He's in.
हेलो अरविंद जी,
हाँ जी, हाँ जी।
आप तैयार है कि अभी और थोड़ा टाइम लें, जैसा आप चाहें?
2 मिनट दे दीजिए बस मुझे।
अच्छा ठीक है, आपके हिसाब से चलेंगे, कोई प्रॉब्लम नहीं है। हाँ।
कॉपी करना है I one. फोटो ले लो उसकी। हेलो
Yes, sir.
हाँ आप आ गए?
बिल्कुल
Yes, sir.
बिल्कुल
Yes, sir.
Can we begin?
Sure, sir.
यस यस
Yeah. So as I shared, the previous part of our present, am I audible now?
यस
Yes, sir.
So as I shared, the previous part of the presentation was more related to different sensors connectivity with the gateway, and the gateway is connected to the cloud. So this was mostly related to the hardware scenario of the solution. So as I know that most of the computer science people are more interested towards protocols, towards programming, or towards dashboard designing, or towards analytics part of the IoT solution. But as an industry, the very first thing which comes is the sensing part, which is very important. So I have shared this part, and now the second part which will be shared, we will share you some of our real-time clouds, which cloud-based applications for air quality monitoring and weather monitoring system. So you will see like we have more than 300 to 400 weather stations which are installed in a different part of the country. Like we have almost 40 to 50 numbers installed in Telangana and Andhra region. Then we have some part in Calcutta and Guwahati, some part into the Sikkim, and some part in Gujarat and Maharashtra. So the good part, you will see, by sitting at one place, I can monitor every information which these weather stations are translating data from their respective location to my location. And once I'm able to collect the data, you will feel ki the different IoT protocols which are quite in demand are MQTT protocol or HTTPS protocol, or maybe some more software libraries which are being used, programmed into the hardware. So very important thing is when we design these libraries and how these libraries goes inside the hardware, that is a very important algorithm. So one part of the software goes into the hardware, which is known as IoT gateway, which knows the address or IP address or the protocol through which the data has to hit the web application. So this communication which happens from the end device to the web application, this interface is very important and crucial. So maybe since the whole presentation, as I shared, is divided into 3 parts, we'll share you some photos and videos also. So here I begin with what we have. Like there are some theory which I will skip it, and so this all people know the different theory, but I will share कि how the different real-time application किस तरीके से हो रहे हैं, and different applications का role क्या है. So you will see this this study which I shared, like IoT for water application. What we have done here in Chandigarh, actually I'm calling from Chandigarh. So here under a smart city project, what we have done is we have monitored different around more than 1,000 water meters, and those water meters collect the data and translate to my cloud-based application. So this is another application which we have shared, which we are going to share with you, like different energy meters which are housed in every house, and how these energy meters, water meters are translating data to my cloud-based application. This whole application we have designed using a combination of two wireless technologies. One is a LoRa-based technology, and then there are some kind of server connected data logging, data protocols. So every energy meter is connected with a small LoRa module, and then you have a LoRa network, and under that LoRa network you connect to a hub, and from that hub we have translated the data to my cloud application. This I have already shared how my agriculture applications are being used. This is where my environmental applications are used. Since our prime area, as I shared, is working for environment, agriculture, and customized applications. So these are the applications which goes into the cloud. Now, some PPT may not be able to give you the real pictures which you are looking forward, but I will share you my another PPT which will have more detailed elaboration. Okay, how this water meter is used, what is the local protocol which we have used, what is the cost for this system, and how this network has been designed. But this I will share with Mr. Lobial maybe in another few minutes, so that he can share with the participants, or I will do it myself. So this is another application which I have shared. Now, cloud-based application, as I shared, is a virtual machines in a local network or data sensors. These web-based services are hosted, which are managed by different vendors. Like we have some kind of Aneka is a part kind of a system which is designing this kind of sole solution. In this kind of system, what we have used in air quality, we have used PM 2.5, PM 10.0, NO2, NH3, CO, CO2. And this gateway is having facility to store data into the SD card. And then using Wi-Fi technology, the whole system is collected data. So it is going to be a combination of a ZigBee technology for near local network, and then LoRa on the other side, and then the GPRS on the other side. So this is how this environment IoT for environment application. This is another application where we have used for water quality application. This is further related to water quality or the flow measurement of the water. So where we have used different parameters like TDS, pH, OROP, dissolved oxygen, turbidity, and we have used this using a MQTT protocol, and we have actuated some kind of relays also, so that some experimentation goes inside, and the whole system is reprogrammable, which a no voice user can just plug and play, and he can interface these devices to the whole system. I mean, this is another slide I have already shared with you. So there's some scratch modules, and this is what we have, a good picture which will try to clear. So here we have used these kind of end sensor nodes which are connected to a coordinator, and through a router it goes to a main coordinator, and under main coordinator it translates data to my cloud-based service. So this is what normally a standard picture, this is a standard diagram where more and more things happens in this kind of scenario. And the client app device application, we have used these kind of mobile devices where we have used excuse me, photos. So this is how the whole picture is. I will show you the live photos also of what end sensor node looks like, and how the coordinator looks like, what is inside of that hardware, and how this master coordinator takes the data from the end nodes and to the router. Major parts which we can conclude is for students or faculty members are these are the different programming languages which we use. We mostly use Python. We use embedded C. We do not use Arduino, but as a beginner, as a fresher level, people may use Arduino. But the real applications is related to ARM-based processor. Just a minute. Okay. So do it once again. So this whole programming part, communication parts, we do API mode or programming interfacing mode or Zigbee interfacing mode, Bluetooth communication or GPRS communication or LoRa based communication, and in different sensors. And then we are using ARM7 processors as a gateway. We are using mostly ARM7 processors. And then we are using Wi-Fi or actuators with, as I shared, with the battery also. And in protocols, you can see that we are so in this algorithm, you will see we are using MQTT protocol or broker and web service, and most of the devices are with the encryption and decryption, which is again another very important factor. So this is how we have shown different interfaces between cloud and end node and sensors and coordinators are how they are happening. Now I will take a small 2 minutes break and will set up the programming part so that my colleague can show you how that a small program can be shared and how the real-time logging can happen. Like I shared about my weather stations or my air quality monitoring systems, I will show you the live dashboard of those, and so that you can see okay how this dashboard collects the data from different places and try to show it to you. And as far as hands-on programming is concerned, my colleague will show you some small example programs and show you the dashboard applications, and then we will take it further. So here I will take a small 1 minute break to set up that, and then we will come back to you again. Lobia sir?
Okay, sir.
Yeah, thank you.
Just a minute.
Yeah. Sure, we'll wait.
Can you show the weather station का वो cloud का?
बस थोड़ा स्क्रीन को फुल स्क्रीन कर दीजिए जब भी करें। हाँ,
क्या सर?
जब भी करें ना स्क्रीन को फुल स्क्रीन, थोड़ा छोटा दिख रहा है नहीं तो।
ठीक है सर, ठीक है। पहले अपना वेदर स्टेशन कर देता हूँ। So here you will see this is what is our login places where you have seen this my ADIPL_logger, and you can use the password.
अच्छा, विजिबल नहीं हो रहा है।
विजिबल नहीं हो रहा है
ना, उसको शेयर करना।
Just a minute अभी।
Yeah.
अब login करो। So now is it visible to you now?
Not yet.
Not yet. Okay.
Your old slides are visible still.
Pardon?
यार पुरानी वाली स्लाइड्स आपकी दिख रही हैं उसके ऊपर।
शेयर नहीं किया तुमने?
हाँ, शेयर नहीं किया।
उसको बंद। ये स्क्रीन शेयर होगा ना? हेलो,
अब आ गया।
Yes sir.
आ गया? अब इसमें वापस जाओ, तुम वहां से वापस जाओ। Now this is you will see
थोड़ा फुल स्क्रीन है क्या? थोड़ा सा फुल स्क्रीन होता तो अच्छा दिखता है।
क्या सर?
थोड़ा छोटा दिख रहा है, फुल स्क्रीन शायद नहीं है।
मैं अभी कर रहा हूँ सर इसको।
हाँ 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 बिल्कुल बिल्कुल, थैंक यू।
अब ओके?
अब बेटर है, पहले से अच्छा है। हाँ
सो नहीं, उसमें जो है ना दूसरा वाला खोलो, weather। हाँ? खोलो। हाँ? चलो ये दिखाता हूँ। हेलो
हेलो।
हाँ लोकेश साहब, आप देख पा रहे हैं?
हाँ देख पा रहे हैं,
हाँ।
पहले से बेटर है काफी।
So you will see here, this is what is my dashboard, and on the upper side you will see this is the automatic weather station. The center is a Chandigarh center, and then this is what is my user ID, and then there are different other sensors which are connected to different location. So when I selected this weather station, I am able to see the real-time temperature, humidity, wind speed, wind direction, dew point, rainfall, and solar radiation. So this is a live reading. This live reading is connected to my IoT based cloud, and then if you go down you will see the live data. So you will see the different parameters like temperature, like humidity, all these parameters, and their real-time graph which has been played. And this data is from which date to which date? This data is from 5th of February to, so this is from 2nd of May to 1st of June. So this is last 1 month's data is being shown to you here. You can also see different data patterns if you select and go to some other places. And this data which is being shown to you is in the Excel format like here also. You will see here like 1st of June at what temperature, like this is 3:30. The last sample which we have taken is at 3:30. So you will find at 3:30 what was the temperature, what was the humidity, wind speed.
थोड़ा और बड़ा हो सकता है स्क्रीन?
एक सेकेंड अभी देखते हैं। अब सही है?
अब ठीक है। यस यस, ओके, वेरी गुड।
You will see here कि this is the date, temperature, and this is the time at which the sample has been taken. So the last sample which has been taken was at 3:30, and that at 3 o'clock. And so once you keep going down, you will see that after every 30 minutes, a sample is taken and the values are being displayed over this place in a different format. And then you want to see in the graph form, so the data is being shown into the graphical presentation also. So this is what is known as dashboard designing. So any IoT application at the end of the day comes in the form of it, how my data is being shown. So this application which I'm showing to you is designed in a Python and a combination of Java on my web application. And similarly, once you have collected the data, you can see the different reports coming here. If you go here, you can see this is of 31st of May. And then if you go here, you will see here, this is for such a temperature 1 June. बाकी क्या
थ्रेशोल्ड रखी होगी, थ्रेशोल्ड रखी होगी,
किसी की थ्रेशोल्ड
ये उसका भी थ्रेशोल्ड ये थ्रेशोल्ड की रीडिंग है जब कोई एक क्रिटिकल पॉइंट से ऊपर हो जाए।
ओके, बट लास्ट रीडिंग यहाँ पे मुझे दिखा तो ये वाला
ये शो कर दिया, तो अब दिया होगा।
Now you can see these readings are for last month, 7th of May, 7th of May at 9:40. This data was the real-time data which has been shown to you here. ये आपको दिख रहा है?
थोड़ा बड़ा कर दीजिए.
थोड़ा बड़ा. अब आया?
थोड़ा सा और है.
थोड़ा सा.
अब ठीक है. अब दिख रहा है.
ठीक है ना? तो ये तो बहुत ज्यादा बड़ा हो गया.
ये ज्यादा बड़ा हो गया, कुछ कट रहा है, बट ठीक है, दिख रहा है. दिस इज फाइन. आप घटाइए बता.
जिस तरीके से हम लोग डैशबोर्ड बनाते हैं और रियल टाइम सेंसर्स को वैल्यू के लेते हैं, दिस इज वेयर एप्लीकेशन कम्स इनटू द पिक्चर. ना अभी मैं आपको, चूंकि रिजोल्यूशन सही नहीं है, आई वांट टू शो सम एनालिटिक्स आल्सो व्हिच वी हैव पुट इट इनटू आवर system. These analytics says if my temperature and my humidity both goes up to higher level, then this action need to be taken, or what time my humidity has gone up to what level, or what time my maximum rain, when the rain was maximum, what value of temperature and humidity was there. So based on these data mining, we can identify the future predictions. So this is where I would like to show my dashboards are being designed in this fashion, where this whole information is being shown in real time. And इसमें हम लोग रिपोर्ट कैसे निकालेंगे? So if you go to the reports, you will find it.
थोड़ा सा बड़ा, थोड़ा make it little bigger.
Actually अब इससे ज्यादा बड़ा करूंगा ना तो थोड़ा सा, अभी आपको दिख रहा है?
अच्छा, हाँ वो दिख रहा है, ऊपर नहीं दिख रहा, डेटा तो नीचे दिख रहा है.
अच्छा, नहीं, ये जब हम यहाँ पे रिपोर्ट्स में जब जाएंगे और एनालिसिस में जब आप जाएंगे तो आप देख सकते हैं कि टेम्परेचर के रिपोर्ट्स में आपको सिर्फ टेम्परेचर दिखाएगा, और एनालिसिस जब हम लोग जाएंगे यहाँ पे करने के लिए तो एनालिसिस में इन सभी पॉइंट्स का एक दूसरे के साथ क्या रेफरेंस आ रहा है, उस सारी चीजों की प्रोग्रामिंग को हमने इसमें करके दिखाया हुआ है, which I am not able to show it because of the नेट की स्पीड थोड़ी सी स्लो हो रही है, इसकी वजह से ये स्लो. हाँ, अब आप ये देखिए, now this whole system is showing only my temperature values. Now other values are gone, but when you go into the analysis mode में, you can see, okay, what is the maximum temperature, what is the minimum temperature. Hello.
Yes sir.
Yeah.
एक सेकंड. तो यार दूसरा चलो, जब तक ये मे बी क्या कहते हैं नेट स्लो है, आपको मेरी आवाज सुनाई दे रही है?
Yes sir. Yes sir. So actually some of the participants are requesting for not using Hindi.
Not using
Hindi.
Okay, no issues. Yeah. We can continue with English.
Thank you.
And maybe till the time there's some problem in internet, so the site is little not responding. He will show you one application which he has designed into MQTT. दिखा सकते हैं? हाँ, दिखा. A small example he will show you in Things to Speak.
Good, great.
इनको पूरा बताना है, क्या बताना?
बताओ.
Hello. So I have created a ThingSpeak cloud, right? I have created this ThingSpeak cloud using my email ID and password. We can create a channels, more channel we want to create. Name for channel.
आपको ये स्क्रीन दिखाई दे रहा है?
यस यस
हाँ, अब इसमें दो तरीके हैं। एक हम आपको अपना जो क्लाउड का एप्लीकेशन है वो दिखा देते। अभी जो थिंग्स स्पीक करके ये प्राइवेट और फ्री क्लाउड है, इस पे ये एक एप्लीकेशन बता के आपको दिखाएंगे कि कैसे एक स्मॉल एप्लीकेशंस को डिजाइन किया जा सकता है। लेटर ऑन वी विल शो यू कि हमारे हार्डवेयर में हम लोगों ने किस तरीके से सी प्रोग्राम के अंदर इसको इम्बेड किया हुआ है। तो आप एक मिनट इनका ये एप्लीकेशन देखिए कि हाउ ही हैज डिफाइंड द चैनल्स एंड हाउ द डेटा इज बीइंग ट्रांसलेटेड from a end device to a freeware cloud. ThingSpeak is a freeware cloud where many hobbyists and enthusiasts they are using ThingSpeak. So I thought it will be very easy for you to see okay how this configuration is being done.
Hello sir. Let's suppose we have to create a data logger cloud. Like example take of air quality. We name it air quality. Suppose first reading will be the CO2 sensor reading. Second reading will be NO2 reading. Third reading will be SO2 reading. Now we have to save this channel. After I save this, it create a graph table. So how we send their data? For this we use API keys. Here is the API keys to write and to read from the cloud. This is a read API key. I am giving you a demo how to send data. I copied this link. And paste it here. Suppose I have CO2 right now 400 ppm, NO2 1 ppm, and SO2 2 ppm. If I enter it here, you will see it display a number. Can you see this number?
Can you make it a little bigger?
What sir?
अब ठीक है, one is visible, one लिखा है ना, that is visible, ठीक है.
Okay sir. It represents there is only one data in a cloud, and the data will be 400 for CO2, 1 for NO2, and sorry. If we check it here, we get the data.
Sorry to interrupt, the screen is not visible. The screen is not visible. The screen is not visible.
Okay, okay. Can you see the screen?
No, no, no. Please share it again. Share the screen again.
Okay, okay, wait.
Okay, it's fine. It's visible now.
So let me after creating a cloud, I have created a 3 channel here. First one was for CO2 sensor. if it is visible to you. Second one for NO2 sensor. Third one is for SO2 sensor. Now to send data to these cloud, these field, we can use the API keys here. How we can send by these API keys? There is link here. We can copy this link when we want to write into this cloud. We paste here. Field 1 is for CO2 sensor. Suppose we have 400 value for CO2 sensors. And field 2 is for SO2 sensor. And we have for SO2 sensor value is 1. And last field is NO2. Third field, let's suppose this value is 4. When we press enter here, you can see here it represents 2. This means there is 2 data on the cloud. If you see here, you get 2 readings here. One is 400 CO2 for, and another one is also 400. There is one for NO2, and last one is SO2. You can use Wi-Fi module or GSM to send data to this cloud. How to use Wi-Fi module? I am using right now ESP Wi-Fi module. For this, I am using a serial terminal. Is it visible to you?
Yes, it is visible. But if it is possible, can you zoom it? Now I am going to demonstrate how to send data from Node Wi-Fi module. For this, first we have to check is mode MCU is connected or not. If it is written OK, then it was connected. It is connected to the PC. To connect to a network, we have a command called AT plus CWJP. Wi-Fi username.
कितना दिन लगा वहां से जाने में?
आप इधर से जाएंगे।
क्यों?
इधर स्विच करने के लिए।
दिन नहीं करना, तो शाम को नहीं कर सकते थे वो काम?
सर हम क्या अगर चक्कर लगा तो मतलब क्या होगा? Now you can see here, this is a command for Node MCU, and this is username for Wi-Fi router, and this is password. If I send this, and sorry, we have to enter last. If it connected to network, then it will send OK. Now the next is to connect to the HTTP server. How to connect this? We can call a command called sips. It is linked. Now I have to copy this line here. Now to send the data, we have to we require length of the data. So it represent here 73 length. So I am sending 74 length data. It's sending unlink. It is unlink. So we have to send here it again. It is link again. Now I have to send this, then this, and last we have to send this command. It is sending okay. Let's check here. One minute. Okay, 1 second. First we connect here. Okay. Second is here. Now if we check here, you will see we get here 0 value. We had only said filled 1 value, filled 1 0 value. If we want to change here filled value, let's suppose 200 value, then we send this command again. It is linked here. Then now length is 75, so we will send here 76. Then this one, and last command is this. Here again. Now we get here 200 value. So by this we can send any data to the cloud using a Wi-Fi modules. We can use any GSM SIM, and any other Ethernet like module to send data to the cloud.
Hello.
Yes, sir.
Yeah, Lobial ji.
Yes, Arvind.
Yeah, Mr. Lobial. So what this guy tried to show you is how he can use a freeware cloud and how he can translate a data from a module which is with Wi-Fi connected. So he has used the two terminals. Through one terminal, he has set up the data buffer length, the value of the sensor, and then he tried to depict it on the cloud. Okay, how this dashboard, which is a configurable dashboard, this is not an actual dashboard, but this is a configurable dashboard which can be designed. So in future, if a faculty or a professor or a student who want to experiment, they can use this kind of dashboard and they can play with the small devices so that they can see the real-time data coming to them. For example, if I take a small potentiometer or a variable resistance, if I connect it with my router and if I rotate it, I can see actual values varying from 0 to 5 volt and from 5 volt to 0 volt. And so the people can be excited. Oh, see, my data is coming onto the cloud. So the very first function, this is very small. This is the most basic function which he has tried to show you, because in this small time, it is not possible for to display more and more things. But here we have tried to show you the real-time applications which we have developed, the real-time scenarios, the connectivity diagram, how it happens, what are the different wireless protocol like ZigBee, like LoRa, like GPRS, like Ethernet, they can be configured. Their role is only to take the data from physical value to the cloud-based data entry points. So I feel that this will give you a little idea that when we people design an industrial application, we need to see, okay, where we have to use the Wi-Fi module, where we have to use LoRa module, where we have to use GPRS, because every application is different and every contents are being designed and packed as per the customer's requirement or the project requirement. So in future, in case any of your faculty member comes up with certain kind of queries, okay, if they want to design or develop a IoT based application, maybe we can help them, or they can share to us, and maybe we can take that ahead. So here I conclude my presentation, and in case you feel there is some questions or queries, maybe I will be happy to reply the same.
Yeah. Can you take few questions for 5-10 minutes if you have time?
Sure.
Yeah. Sakshi?
Yes, sir. Yes, sir. Thank you so much, sir. I request participants, those who want to ask question, please raise hand. Okay, we have Mr. Raju.
Yes, Mr. Raju, can you share me your question?
Yeah, sir. Sir, nice session, sir, today. Sir, good evening, sir. Am I audible, sir?
Yeah, you're properly audible, sir.
Sir, we can use ThinkSpeak.
The ThinkSpeak is
Yeah. ThinkSpeak is a cloud, sir. Yeah, I know, sir. I know ThinkSpeak is a cloud. So instead of ThinkSpeak, you can use Plotty.
What do you say?
Plotty.
Okay.
So how will you use, sir? Plotty is how will you use?
Maybe I'm not the right person who can reply how I'm going to use Plotty, but in case you can put a small line, so I will ask with my team members who are the developers, who they can definitely reply how they are going to use this software.
Okay, sir. Okay. Sir, one more doubt, sir.
Important thing is we have shown you the ThinkSpeak, because we do not use ThinkSpeak. We have our own web applications, we have our own web service, but in this short period of time, it was not possible to show you the detailed of our web application. Hello?
Yes, sir. Tell me, sir.
So,
I listen, sir.
So that is why we thought, okay, by using this freeware cloud, maybe you people will have a little about the same.
Hello, sir. Hello.
Yes,
Hello. Tell
please.
me, sir.
Yes, sir. I have one more doubt, sir. I have one more doubt.
Please
So,
tell.
yeah, regarding soil parameters, is there any separate data sets are available?
Can you repeat yourself?
Regarding soil parameters like soil the temperature, humidity, moisture, pH value, conductivity value, regarding those parameters, is there any free data sets are available?
Free data sets available.
So some sites are there. So could you please give some sites?
Price.
Some.
Hello.
Hello, sir.
What do you want to know? You want to know the price for the sensors?
No, not price. Data sets.
Of course. Maybe there are soil, as you know, varies from location to location. We have used in Punjab, we have used in other places. So you can have a special soil logged out values which we can share with you.
Yes, sir. I need that value, sir.
So I can share with you because we have used in different locations. These, as I shared, the soil varies with the location. So
yes, sir.
if I happen to get something, I will definitely share with you.
Thank you so much, sir. Thank you so much, sir. Thank you, sir.
Hello, good afternoon, sir. Hello.
Yes, sir, you are audible. Please ask your question.
Sir, it was really a nice session in which we came to know various scenarios used in industry, in IoT especially. Sir, my question is not technical, but I want to know what are the kind of job profiles that are available for the fresher from BTech or even from a diploma holder. Because we keep on teaching the fundamental of this IoT in our classes, but we are not sure, even the parents of the students are not sure what kind of jobs are available for.
I will share one small example, like in an automobile industry, or car manufacturing industry. There are hundreds of applications where every kind of engineers gets fit in. If it is a ITI or diploma or engineering or MTech or PhD or research, everybody has got a application into automobile sector. So the same thing is available with IoT also. There are a time when you need small guys like ITI or diploma holders to install the IoT gateways into the field, calibrate the sensors, calibration of IoT values going to the cloud. So in case a person knows the networking properly, or if he knows the practical field application, so it depends what is the profile of the person. If there are different positions for ITI or diploma or electronics or computer science guys or in fact the mechanical guys also, because the way you are going to fit a sensor, the way you are going to interface a sensor with the end device, all things are possible. IoT is a really very big domain. It caters to the most of the people if they are interested to develop a career into the IoT based application.
Okay, thank you, sir.
Next is
Good
Dr.
evening, sir.
Sheikh.
Good evening, sir.
Yeah.
Yes, sir. Yes, you are
In
audible.
your application, how many layers you are implemented so that it is generally we have a OSI, it will be the 7 layers. So are you consider for your implementation 3 layers or 5 layers architecture? If it is implemented, how you are providing to the security?
So can you repeat your question once again? Actually, some part I have missed.
Sir, in your IoT application, how many levels you are considering? Suppose if it is an OSI, it will be the 7 layers. So generally we are TCP/IP reference, we are considering to the 4 layers. Some of the IoT applications they are implemented within a three layers. So in this, how you are accommodating to that security feature? It is an authentication in application level, or it is that in a gateway level. How do you are accommodating that? It is
So can I reply your question?
Yes, sir.
So as far as security layer is concerned, my security is at both the levels. We have the security at the gateway level also, as well as on the edge level also. So one is there, we are using AES encryption, decryption algorithms, which we are putting into the application layer. So some of my application layers have got different security level. My data layer has got different security level. And sometimes what happens, it depends upon application to application. So there are different encryption, decryption, and security levels which are being employed into the application side as well as onto the data gathering side. So these are some of the layers on which our security levels varies. Maybe if you have any other query, maybe you can write me an email. I will share with my technical team and I can reply you.
Thank you, sir. Thank you.
Thank you.
Hello, sir.
Sir.
Hello.
Yes.
Hello.
Sakshi.
Mr. Prabhakaran, you are not audible.
Hello, sir.
Yes, sir. So you are not clear. Your voice is not clear. Can you write the
Good
question?
evening, sir. Prabhakaran from JP Institute of Technology.
Sakshi.
Mr. Prabhakaran? Yes, sir. Yes, sir.
Sakshi.
Yes, sir.
Sakshi, will it be good if you can have a written questions? Maybe tomorrow I can reply because I have to leave the place to.
Absolutely, sir. Not an issue.
So in case
Sure, sure.
possible, we can connect tomorrow by through an email or so.
Yes, sir. Yes, sir. I request the participants to write their query and mail to sir so that he can answer later on.
You can have a copy of the queries. Maybe tomorrow, if you can, you already have my email ID. You can put me a small email. I will reply in the night only, and I can reply that.
Sure, sir. Sure, sir.
Okay, thank you, participants, for your valuable time. I tried my level best to share whatever I can in a small period of time, and since it becomes a little difficult when you do not know, when you do not see the audience. So maybe some part may be missing, but anyway, it was a great experience sharing this.
Thank you so much, sir. That was really a wonderful session.
And please pay my regards to Dr. Karan if he is around.
No, sir. I guess he's a bit busy today.
No issues, no issues. Give my regards to him and share the details to my email.
Sure, sir. Thank you so much, sir.
Sakshi, have you noted down my email ID and website?
Yes, sir. I'm having it.
So you can drop me a small email.
Okay, sir. Okay.
Thank you. Thank you.
I request Professor Lobial, FDP coordinator, to extend a warm vote of thanks to our honorable speaker, Mr. Arvind Dixit. Lobial, sir.
Okay. Yeah, I'm here. Thank you, Arvind, for a wonderful session. And despite of all difficulties with the connectivity, you have been able to give a good practical as well as the theoretical aspect of how the products are being designed in the industry and different kind of applications where you are working on. Take it agriculture, take it environmental, and take it on water management. It's a good application, as well as you have given participants that if some of them are really willing to work, they can use on ThinkSpeak to certain extent how the programming is being done. May not be on the real products, but they can learn it. And it has really made the participants very exciting, and they will definitely ask you certain questions because IoT itself is a very exciting area where people are interested now. It has a good future as well. So thank you for spending time with us and sharing your knowledge of your product design in the industry. Thank you very much. We'll see for future cooperations as well.
Sure. Thank you,
Thank
Mr.
you, sir. Karan sir is in.
Yeah.
Thank you.
Hello, Arvind. Hello.
Hello, sir. How are you, sir?
Yeah. Hello.
Hello, sir. Hello.
We have got meet before this meeting. So there is a Professor D.K. Lobial.
Yes, sir. Yes, sir.
He is the coordinator of the event.
Okay.
And I am also associated with this event. So
Okay.
we will again call you if we require.
Sure.
Okay.
Once again, thanks to you. Maybe we have never met each other, but
Yeah.
We have spoken to each other quite a number of times, and hope to see you in future. And
yes, certainly very soon.
Hello. Hello.
Yeah, certainly we'll meet very soon.
Yeah, we will take this association ahead, and we'll keep in touch with each other.
Thank you so much.
Thank you.
Kindly share your material if possible. Some
Yes, sure. Please ask Sakshi to send me an email. I will reply on the same.
I will send. No issue.
Sure. You can also send to me.
Yeah.
Thank you, Lobia sir.
Thank you, Dixit ji.
Thank you.
Such a wonderful system.
Thank you.
Thank you, sir. So with this, we end with the session today. So, sir, is there anything else to convey, or let's end the meeting?
Lobel sir.
Lobel sir, is there anything else to convey to the participants?
अभी तो कुछ नहीं और कुछ information कुछ
So your voice is not audible. Okay, it's fine.
बता दो लोग तैयार रहेंगे भाई. Karan?
Yes, sir.
Whatever to be done, they should be told in the beginning so they can be mentally prepared for, है ना? कुछ है?
एग्जाम के लिए सर.
हाँ है कुछ ऐसा तो मुझे नहीं आइडिया है.
If they have any query, we will take and respond.
AICT की requirement, if any requirement from AICT.
There is some requirement according to AICT. They are saying you should maintain the 60% criteria for marks. So suppose there is a quiz, then you just maintain the 60% marks. Suppose there is 100 marks is there in quiz. We will take the quiz in form of the multiple kind of the question. So there will be 4 answers. And one will be right one. There is no negative marking. So we will try to take all questions from session. So already we have posted the material of the each session. If we receive, then immediately we send the in group, as well as we will try to maintain our website. So there is some issue, we will resolve that. So if still there is any query or any issue related to exam or related to event, so any participant send the his or her view in our IoT group. So there is already we have created one WhatsApp group. So they will share any query. Okay, sir.
Yeah.
Okay, thank you, sir.
ठीक है.
Well, with this we end with our session. We'll be meeting tomorrow at 10 a.m. Thank you all.
So tomorrow it will be start at right time. Tomorrow also in the morning there is a some hands-on session via virtual lab.
Okay, sir.
Tomorrow morning.
ठीक है भाई सागर.
हाँ, गुड इवनिंग सर.
गुड इवनिंग.
हाँ, कैसे हैं सर?
बढ़िया.
ये बहुत अच्छा रहा सर, बहुत इंफॉर्मेटिव रहा आज का हैंड्स ऑन सेशन था, तो बहुत अच्छा लगा.
ये जो आइगन वाला है ना, उसमें भी यही आएगा. वो उनके भी अपने प्रोडक्ट है, वो भी यही करते हैं.
जी सर. उसका इनका अपना ये इंडस्ट्री है ना अरविंद.
ये सब यही करते हैं. आइगन वाला भी जिससे मैंने खरीदा, उनके भी प्रोडक्ट इसी तरह के होते हैं.
जी सर. नहीं, बहुत अच्छा सर, बहुत अच्छा. और जो कलेक्शन है ना आपका, जो सेशन का है, वो अल्टीमेट है. एक से एक बढ़ के है ना इसमें सेशन लगाए.
ये करण सिंह रिसर्च करता है, वो पता नहीं कहाँ से ढूंढ के लाता है.
करण सर का नेटवर्क चलता रहता हमेशा.
ये मेरे से जुड़े हुए कम से कम 5-6 साल से.
अकाउंट तो वेरीफाई होने दो, कर देंगे 6 बजे तक. कहा ना
सर, करण सर के पॉकेट में बहुत सारे जेम्स है अभी भी.
अरे पॉकेट मेरी ओपन है बिल्कुल, उसमें कुछ नहीं है.
करण सर के थैले में बहुत सारे जेम्स हैं.
मैंने अकाउंट ऐड कर दिया.
बहुत सारे नगीने रखे हुए हैं सर ने.
मैसेज आएगा, मैसेज में
मैंने कहा करण सर के पास बहुत सारे डायमंड्स हैं अभी भी. वो टाइम टू टाइम जो है आते रहते हैं.
मेरे पास ओपन है बिल्कुल.
अच्छा करण सर, सबसे पहले तो अद्विका के जन्मदिन की हार्दिक शुभकामनाएं, अद्विका को भी और अद्विका के मम्मी पापा को भी.
धन्यवाद. अभी उसी की तैयारी में लगेंगे थोड़ी देर में.
ऐसा है ना, जब तक बच्चों की समझ में नहीं आता तो सारे मम्मी पापा को ही देना पड़ता है भाई.
हम लोगों का ही बर्थडे समझिए आप.
है बिल्कुल.
ये सेलिब्रेशन की तैयारी शुरू हो गई है, लग रहा है पीछे बैकग्राउंड में दिख रही है।
अरे ये भाविका ने किया।
हाँ वही कह रहा हूँ, भाविका ने लगा दिए लग रहा है बैलून्स।
मैं तो मीटिंग में बैठा हुआ हूँ।
जी 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 जी।
ओके।
अभी आपको केक मिलेगा सर, वेट करिए।
वर्चुअल केक?
नहीं, तुम केक इसी पर भी काट सकते हो, सबको दिख जाएगा।
सर
देखिए केक बना रहे हैं मैं और भाविका
घर में बना।
बहुत बढ़िया,
भाभी जी
बहुत अच्छा।
ये घर का केक है।
बन गया? वाह,
बहुत सुंदर बनाया है भाभी जी, बहुत बहुत बधाई आपको भी।
अरे मैं तो अभी छापा भी मार सकता हूँ।
आ जाइए बिल्कुल सर, ये देखिए
आ जाएंगे तो अच्छा से।
सर आपकी अपॉर्चुनिटी है, हम लोग तो नहीं आ पा रहे हैं।
सर आप लोगों का ड्यू है।
हाँ बहुत
पक्का डेफिनेटली, और जब भी आएंगे पक्का केक खाएंगे इस बार।
बिल्कुल सर।
बाहर वालों को तो बिल्कुल अलाउ नहीं कर रहे हो।
चलिए, मैसेज भी अभी नहीं हुआ ना।
सर केवल जेएनयू वालों के लिए है आज केक।
हाँ ये लोबियाल सर।
यस
ये रिकॉर्डिंग आप पॉज कर सकते हैं।
अच्छा हाँ, नहीं तो ये भी रिकॉर्ड हो जाएगा।